como mais um episódio, não? É ou não é?
This is week 1, 0 index, so to speak, and it's not every day that you say that you learned a new language, but today is that day. Today we explore a more traditional older language called C, and rest assured that even if what you're about to see, no pun intended, looks very cryptic, very unusual, particularly if you're among those less comfortable, cling to the ideas from last week 0, where we talked about the fundamentals of functions and groups and conditionals, all of which are coming back today. Indeed, whereas last week, in Microfones 0, focused on learning how to program with Scratch, again, when it's played with, as it your students days back, I'm going to focus on C instead. But along the way, we're going to focus, as always, frankly, on learning how to solve problems. What I want to do today, later, prepare past like this, is just to give you week after week all the more tools for your toolkit, so to speak, by which to do exactly that. So for instance, today, we'll learn how to solve problems more so with functions. As for last week, we'll do the same with variables, we'll do the same with conditionals, with loops, and more. But we'll also learn at the end of today's class really how to solve problems. It turns out it's powerful with Max and self-taught nowadays. There's certain things that they can't do very well, and maybe they can't represent it very well, that actually leads to a lot of real-world problems. So past and surely leads you. So more on what we're not going to be able to do with programming anymore. But beyond that, let's come back to the picture here. So this was a very first program that I wrote, that you wrote, presumably in some form, and all it does is say hello world. But as today, this puzzle piece, with these puzzle pieces together, we're going to very quickly start to look more like this. And I've deliberately color-coded it in a way that the text on the screen now kind of resembles puzzle pieces. Notice we have this green flag click puzzle piece, both green and yellow green flag, which kicks off the whole process. You actually click the button and top right, you'll scratch out your face. And then there's a couple block, which actually is the verb action function that does something. So if I bring this back to what we're about to see today, there's going to be some boilerplate, so to speak, some orange text that for now, just kind of type it, granted, like white or like that. The more interesting is going to be purple. And we're going to say a function that we will say is now called printf in this language called C, but in white here, this is similar to our white label last week, whereby that's where users like your programmer can actually go. So there's a lot of distraction on these kinds of things that can distract and get frustrating when learning code for the first time, but the ideas, most importantly, are going to be the same. So how are we going to go about using this? Well, it turns out, like last week, we're incorporating something called source code. So code, as you know, what it's called source code. That's what you and I humans actually write. And indeed, it might look a little something like we just saw. But unfortunately, computers only speak this, binary 0 to 1, more commonly known as machine code. In other words, those same patterns 0 to 1 last week, some guessed print out hello world on the screen, because some one pattern is H, another pattern is E, and L, and L, and O, and so forth. And then other patterns of 0 to 1 are commands or instructions to the computer that literally say, show HELLO, comma world on the screen. But machine code would not be nearly as much fun to write if it were indeed in 0 to 1 entirely for us. Ideally, you and I are going to write source code, which conceptually sort of up here, high level, but we're going to need a program to convert it to the lower level machine code so that we don't spend our lives having to read and write 0 to 1. Which back in the day, kind of yesteryear, you kind of sort of did called punch cards and holes on this sheets of paper. We're beyond that. After years and years of innovation, folks have given us higher level languages instead. So here's what we're going to do today. If at the end of the day, you and I are writing source code, but we want machine code as output, we need something in the middle that's going to convert that source code to machine code. You and I are going to have to learn to talk about probably more 0 to 1. And the type of program we're going to use today, and it's used to, is called a compiler. So a compiler is a program that translates one language to another. And it can be any two languages. But today, often we talk about it in the context of source code to machine code. So this is Apple or Google or Microsoft or folks from other companies who volunteer to bring software to conversion. You and I are essentially going to download a free compiler and use it to actually get our computer to understand the source code that you and I write in these higher level languages. So where are we going to do that? Well, we could actually give you instructions. You could download the appropriate free open source software onto your Mac or PC. The reality is that creates so many technical support headaches. We all have slightly different computers. We all have slightly different versions of Windows or Mac OS or Linux or other operating systems, and it's too easy to distract at the beginning of any course like this or learning programming. So we're going to use the cloud instead. We're going to use a URL of the form https://cs15.dev. And what this will do for you is look inside of your browser window absolutely everything we need for the course, but it's going to use software called Visual Studio Code, otherwise VS Code, that's actually free itself. It's very popular in the industry. It's what real programmers use every day, but it's a cloud-based version thereof. So everything will just work for you out of the box. But toward the end of CS15, the goal is going to be to get you off of CS15's infrastructure, to get you to download this free development software onto your own Mac or PC if you so choose, so that those train wheels, so to speak, come off. And even if you never take another class again, you don't need any class infrastructure moving forward. Everything you want and need on your own Mac or PC. But for now, it'll save us this. So in just a bit, I'm going to go to that URL myself on my computer, and I will see a user interface that looks a little something like this. The colors might be different, different settings, fonts might be different, and so forth, but in general, it consists of a few different regions. So over here at the top is where we are going to start writing code today. So it's a tab interface, like a number of programs nowadays, and this is that same C code that we saw a moment ago. So this is where we're going to start typing. Over here at the bottom is what we're going to call a terminal window, or a console. And the terminal window is where we're going to type commands for compiling our code, for running our code. And we see today a contrast between a graphical user interface, or GUI, which has menus and icons and click and are very familiar with, versus a command line interface, or CLI. And so we're using both of these together. And command line interface, which means down here, you only use your keyboard. You can click if you want, but now it's not too much, because the command line interface takes commands from the keyboard. So in here, it's going to feel like taking a step backwards from the Macs, the PCs, the iPhones, and the we all have, which are very practical. But it turns out once you become a computer person or a programmer, you can be a lot more productive, a lot more efficient, I dare say, by learning the hard command line interface and using both types of interfaces and what each of them. So more on that in just a bit. Over here at your left, you're going to see soon a folder interface like Mac OS or Windows, where any of the files or folders created in CS15 are going to end up as well. So it gives you sort of the best of both worlds. You can click on the left, or you can type commands at the bottom, as we'll soon see. And then along here is so-called activity, which is VS Code specific features, but also CS15 specific features. And if you're in your own version of CS15.dev, you click through the dot menu or zoom out so you can see everything. You'll see CS15's own rubber duck, virtually speaking. It will be there throughout the course to answer any and all of your questions as well. So more on that soon too. So here's the code that I propose that we write first, just like you wrote your very first program, to say hello world. So let's go ahead and do exactly that. So I'm going to switch over to this screen here, where I've already logged into CS15.dev on my computer. And just to keep the focus on the code, I've hidden the FTP bar, I've hidden the file explorer, so to speak. So you're seeing here the area where all my tabs are about, and the terminal of my command window. But I've just simplified the UI to focus on the integration process. So how do I go about actually writing and compiling and running some code? Well, it's easier. There are these steps. One of these is a command called code, and code is going to let me open or create a file. File called hello.c. Main is going to be, for now, my compiler that allows me to make a program that converts source code into machine code. So for the C, 0 to 1. And then weirdly, you'll see my /low is going to be the command to run my actual code. So the textual equivalent of like double-clicking on a Mac or PC C icon or tapping icon on your phone. So that's it. These three commands are to write, to compile, and to run code multiple. So let's go ahead and do that. Back in my VS Code interface, I'm going to go ahead and run code hello.c. And notice a couple of details here. So one, there's this weird dollar sign, which has nothing to do with currency, but it's just a common convention in the programming world to represent your prompt. So if it's TF5 goes to your prompt, we really go to your terminal and go to the dollar sign, and the dollar sign is where you type the command. Sometimes it's a symbol, but the dollar sign is convention. Now that I've typed code space hello.c, I'm going to go ahead and enter. Maybe not surprisingly, this is a brand new tab, new file, if you will, called hello.c. And just like Word documents have their own file extensions, like .docx, and Excel files have .xlsx, and .pdf, .pdf, GIF, .gif, and so forth, so do C files have a file extension by convention that is .c. Now a couple of minor points. Notice that by convention, I'm almost always going to name my files in lowercase. By convention, I'm never going to use spaces in my file name, and my file extension 2 is going to be lowercase. Long story short, accidentally hitting the space bar or using file names with spaces just tends to make life harder when you're command line environment. So just beware, silly, stupid things like that. So all lowercase, no spaces. So my cursor is literally pointing because the programmer wants me to write some code. I'm going to do this from memory. You presumably sometimes require the same instance, but I'm going to go ahead and type this first line here, pronounced include standard IO.h. More on that soon. Int main void. Notice what's about to happen. There's a little interest. In the code I want to type, I want what we'll call curly braces, sort of squiggles. We don't use often in English, at least, but are there on the keyboard somewhere. But notice what VS Code does in a lot of programming environments is it finishes part of my file. So I'm only going to type a left curly brace. But notice, I actually get two of them. And if I hit enter, notice that not only does it switch one down, it also indents my cursor, because just like the pseudocode last week, whenever you're doing something logically that should only happen if something above it happens, similarly is indentation can be a thing when we actually write code. So VS Code and programs like it, just try to save us some strokes, so I don't have to waste time like hitting the space bar or hitting tab or sort of wasting my human time like that. Alright, so with that said, I'm going to go ahead and type the last of these lines, print f, where the f is going to be formatted, and then in parentheses, and notice I gave you two, give me the second one for free. Sometimes when you can certainly override this, delete it, and start over. And now unlike scratch, in C, it turns out I'm going to use double quotes anytime I'm using an English word or phrase, any human language for that matter. Hello, comma, world, and then at the very end of my line, much like English uses periods, I'm going to use a semicolon in C. So that's a lot of talking, but it's not much coding. It's technically 6 lines of code, but honestly, the only interesting one intellectually, as you can see, is really line. That is the equivalent of that say block. Now here's where I cross my fingers, hoping that I can make any typographical errors. It's going to automatically save for me, and I'm going to go back to my terminal window, where now I'm going to do that second command, make space hello. Common mistake, you do not say make hello.c, because you already made that file. You say make hello, which is the name of the program, and in this case, I use my to create. And make it smart, it's going to look in my folder, and if it sees a file called hello.c, it's going to convert that source code to machine code, and save the results in a simpler, shorter name file called hello, like icon on your desktop. Now hopefully nothing happened, and that is a good thing, quite paradoxically. If you do anything wrong, programming on many lines of errors, telling you you made a mistake, seeing nothing happen is actually a good solution. So the last command to run my code, recall our 3 steps here. We create code, create the file, make it, to compile the file from source code to machine code, so lastly is /hello. So this now is the equivalent of my like double clicking on a Mac or PC or single tapping on a phone. Enter. So close. Alright, pretty good. I got HTML, world, but there's something a little stupid about what might rub some of you SFs in the wrong way. Yeah, so the dollar sign looks like I was like, hello, dollar sign in my output, but no, that's just kind of a remnant of my prompt starting with a dollar sign. And this is a little nitty, but this doesn't feel right, it doesn't look right, it's not quite correct. So how can I go about fixing this? Well, here's where, at least initially, it's going to take some introduction to this new syntax to see to fix it. Like the simplest is they might need to do this. Let me just hit enter like that. But this should soon, not already rub you the wrong way, because in general, we're going to see that programming in C and in Python and other languages is just line based. Like you should really start and finish your thought on one line. So if you're going to have it enter like this and finishing your thought on the next line, generally programming languages don't like that. So this is in fact not going to do what we expect, and just to show you as much, I'm going to do this in the back of my terminal window here. I'm going to rerun make hello for making that change, enter, and there we have the first of our erroneous outputs, and it's yelling at me, it's missing its terminating character, and it's red and there's some green drawing my attention to it. Sometimes these errors will be straightforward, sometimes you're going to like your brain and figure them out. For now, I've got spoiled it, obviously enter is not the right solution, so let me clear my terminal window to hide that error. Let me delete this, and let me propose now that I add this incantation here. So /n, it turns out, is going to be a sort of magical way of ensuring that you actually get a new line at the end of your output. So let me go ahead now, rerun make hello, because I've changed my code, I need to now recompile the source code to new machine code. /hello, and now, there is the canonical hello world program that I called to write in the first place. So for now, don't worry about include, don't worry about stuff, don't worry about hints or main or void or curly braces, focus primarily on line 5 here, and over the course of today, the next we'll apart the other characters, and now you can take questions on any of these. Yeah. Sure, why is the backslash inside the quotation marks, if you will? So there's like legend of where it needs to be, because inside of the quote is the input that you want printf to output to the screen. So if you want printf, this function, output a new line, it must be included in the quoted text you get. Exactly. /n is a special pattern that printf knows, okay, I should move the cursor to the next line. Good question. Other questions? A good question. So when you actually want to print /n, things get a little tricky there. We go ahead and propose that we do this. So it turns out this is often the case in programming. When you want a literal character to appear, you actually put another / in front of it. This is not something you do often. There is in fact a solution to that. But let me propose that beyond that now, start comparing it back to the here is the first scratch program we wrote for green light. Here we are with the mental model that we have almost everything we do, whereby functions are just like implementations in code of algorithms, step-by-step instructions for solving problems. The input to functions are called multiple arguments or in some context parameters. And sometimes functions have side effects. Like last time with scratch, there was the speech bubble, and as it would appear, here's the has now, it's a sort of side effect of using the save block. So just like this, then we had the white bubble as input. The save block was a function last week, and then we had this here side effect. Well, how do you compare these things left to right? Well, here's the save block at left. Let's compare now to the C code at right. Notice a couple of things to sort of adapt from scratch to C. Print is almost the name of the function. It is technically printf. The reason we'll mention C. Notice the parentheses in C. We're kind of evocative of the oval in scratch, and that's probably why MIT chose an oval, because a lot of languages use parentheses in this way. You can still write hello world just as we did last week in scratch, but for our demo this far, you do need the double quotes, and double quotes, not single quotes. Double quotes go left and right, and in order to get that new line, you need the /n, and one more thing missing. Yeah, the semicolon to finish your thought. So all of these sort of stupid things now, honestly, honestly, you will forget initially if you've never programmed before, but you'll soon, within days, weeks, develop muscle memory, where all of that stuff jumps off the page right at you. All right, so these escapes, this backslash n is generally known, just so you know, as an escape sequence, and so backslash n allows us to specify a character that otherwise hard to type, but let's tease apart some of the other things that help that function already. So include standard io.h. It turns out that in C, a lot of the functionality that comes with the language is tucked away in separate files. So if you want to use certain functions, you have to tell the compiler, hey, I want to do some standard input and output. I want to print something on the screen. And that's because for now, you can think of printf as living in this file, standard io.h. It's a bit of a white lie for now, but in standard io.h is essentially a declaration for printf that will teach the compiler how to print things to the screen. So hash include here simply tells the compiler before it does anything else, essentially go ahead and find the local hard drive file, standard io.h, and kind of copy paste it there, so I know now about printf. So this thing, this .h file, is what we'll technically call a header file. And if you remember this word, which we have programmed before, it represents essentially what we're calling a library. So a library in the world of programming is just code that someone else wrote that you can use. It's usually free, open source, because you can literally see the code that someone else wrote, or sometimes you pay for it. Sometimes it's closed source, which would be Microsoft wrote. They won't show you the code, but they will let you use the zeros and ones. So libraries are super useful because honestly, even I don't really know how printf works. I've taken it for granted for 25 years. I use printf, stuff prints on the screen. But someone smarter than me had actually write the code in C that figures out how to get the H, E, L, L, and so forth onto Mac screen, PC screen, phone screen, or somewhere else. So libraries allow us to stand on each other's shoulders, and so that we have to do the harder work, and we can now solve problems that are more interesting to us. Basically, so again, library code that someone else wrote, header file, and C is just a file, and then .h that gives access to the same. And so for instance, if you want to learn more about these, there are what are called in the world of programming manual pages. And these are textual files, like a documentation source, by which you can learn how a function works or and how you can use its inputs or arguments. The reality is, you're really for folks who aren't in CS50, they're really for folks who aren't just learning how to program, they're really for and by folks who've been programming for years. So frankly, it's a little hard to understand. So specifically, there's a version thereof at this URL, manual.cs50.io, where you'll see not only the official documentation for C, the language, but also staff written simplifications in layperson's terms, what all the various components are, what their inputs and what their outputs are. So for instance, under standard.io.h, you can actually go to that website, you can go to a URL like this, where standard.io.h is in there, you can actually see the documentation there for you. So let's go ahead and do this. I'm going to go ahead and my browser here, I'm going to go to manual.cs50.io, and let me go ahead here and select those functions that are frequently used in CS50. And under standard.io.h, you'll see a bunch of functions, only one of which we can discuss, called printf. I'm going to click on printf there, and you'll see an interface that at first glance might be a little overwhelming, but it's going to start with a little more than So first of all, you'll see that if you want to use printf, under synopsis, you need to include this header file. Like you literally copy and paste that line into your code. You'll also see this, which for now is a bit arcane, but this is kind of a hint as to what the function is going to look like, but more on that soon. But more importantly, you need a description about it. And these descriptions, when you're in less comfortable mode, are written by me, of course, teaching other CC assistants and course assistants, you'll find them much more in layperson terms. So long story short, rely on this site if you want to learn how to use a function, and also what other functions exist. In fact, if I go back to the main page here, you'll see that there are all these functions, like are frequently used in CS50, and there's hundreds more that you can see. But learning programming is not about learning all of those, but rather just getting a sense of where you find answers to questions when you do want to try something.
Oh my god.
Today is that we have our own header file called cs50.h, which has functions that we have written just to make life easier in the first few weeks of the class. These are training wheels, we'll eventually take off, but it turns out in C, especially if you program before, it's actually really hard and annoying just to get input from users to get them to type a word or a number or something else. And C does not make this easy, in part because it's one of the earliest languages that wasn't zeros and ones. So you have to do a lot of that yourself. But we'll put on these training wheels today for a few weeks so that we focus really on some of the interesting ideas of C and programming without being bogged down in certain themes that we will go back to before long. So for instance, if you don't documentation is there at that URL, but within the library, it are these functions. A function called getString to get a string of text. String is a synonym for just text in programming language. So getString is computing for a string of text. GetInt is shorthand for get integer if you want to get a number from you. GetFloat is a little more arcane. Get a floating point number, so a real number with a decimal point in it, dot. There are others as well. So this is to say within CS50, we've got some user-friendly functions by which you can actually get some input. And let's go ahead and use one of these getString. Because we called that last week, our second programming scratch was this one here, where we didn't say hello world, we said hello David, or hello Carter, hello Yulia, whoever it was typing their name in. But to do that, we needed this ask block in Scratch, and then use the save block, and then use the join block to kind of make all of this work. So let's translate this program now to C, because it's a little more interesting and representative of the kind of code we'll start to write. But we need a slightly different mental model. Still have a function here, which is the implementation in code of an algorithm. We still have some inputs called arguments. But previously I said that the save block and in turn printf has side effects, which is just something visually typically that happens on the screen. Other functions actually have what we called last week return values. And this is kind of analogous to a function that is doing something for you, writing down the answer on a slip of paper, and then handing you the program on a slip of paper to do whatever you want with it without just broadcasting the code at speech level on the screen. So a return value is germane for a program like this because recall, when we use the ask block and I type in my name, where did my name end up initially? Didn't go on the screen yet. Where did it end up? In an answer puzzle piece. And that special oval puzzle piece, I claimed at the time, represents a return value. So the sort of metaphorical piece of paper that the answer is written down on so that I can use it later. So that's what we want to get to now and see, a return value that I can do anything I want, whether it's print to the screen, change it in some way, save it in a database, or anything else. So here, for instance, is what we did with Scratch. The input to the save block or the ask block was what's your name, quote unquote. The function, of course, is ask function. The return value was answer. If we now consider how we translate this to C, it's going to look a little weird at first, but it's going to follow a pattern today, next week, the week after, anytime you do code like this. So getString, I claim, is going to be the most analogous function in C to the ask block. And to be clear, this is a specific thing, training wheels of but we'll show you unique what this function is doing and how you can not use it moving forward once you're comfortable with the language itself. Notice that parentheses left and right, sort of a placeholder for user input, and that user input is going to be what's your name. But I can't put what's your name in parentheses, what do I need to add there too? Yeah, so there's no quotes left and right, so I'm going to add those in. I like the space here, not for a new line, I could move the cursor to the next line, but I minimally at least want to move the cursor just one space over to illustrate it, so that when I prompt it for my name, there's a space between the question and my answer. But it could also be backslash n, just an aesthetic choice on my part. But what do I do with the answer that comes back from getString? This is where the text is going to look different today. In C, you start using the equals from left to right respectively, and on the left, you put the name of the variable in which you want to store that return value. So a return value is kind of a conceptual thing. You can do with it what you want. If I want to store it on return on a variable like x or y or z in that class, I can give it a name, x or y or z, or more recently, answer, or any other English word. No spaces, inner lowercase, same characters as before, but this is now, ask the user what's their name, whatever they type in, go ahead and store it from right to left in this variable called answer. But C is not done yet. You've learned Python or some other language, it's kind of done by the code at this point. In C, though, you additionally have to tell the compiler what type of variable you want to use. So if it's a string of text, you say string. If it's an integer or number, you say int, as we might see before. So it's a little more pedantic, more annoying, frankly, more honest than you'll do the programmers, but this just helps the compiler know how to store in the computer memory. I'm so close to being done with this line of code, but what's missing? So semicolon. And mark my words, if you've never programmed before, sometimes this is neat, this semester, you will forget semicolon. You will like raise your hand, you get frustrated, you can't understand why your code is not working. You will run into stupid issues like that, stupid things. They are stupid issues. It doesn't mean it's not something for you as a programmer. It takes time to see these things. It's a new language to do. So there now, my semicolon. All right, let's go ahead then and do something with that return value in the second of the big puzzle pieces of scratch. So when I'm going to say hello, comma, dated, or whatever the name is, I kind of stack my puzzle pieces like this. This is actually similar to Python and some other languages some of you have learned, but C is a little bit different. And the closest analog to this scratch solution is going to look like this. I still use printf. The printf is the equivalent to say. Inside of my parentheses, I'm going to go ahead and say weirdly, hello, comma, %f. So there's no real analog in C of join. Instead, there's a way to specially format text using printf, hence the F in printf. And what you do in printf is like any word or two words that you want. You then use %s as a placeholder. You want a string of text to be added to your own text. You literally write %s. And we anticipate a question from the crowd. How do you print out %s as a solution to that text? You literally never want to print out %s. But it's deliberately a weird choice of characters so that you low and low. All right, that's not quite enough. In addition to saying hello, comma, space, placeholder, %s, and just for vocabulary sake, that's a format code. Again, format being the F in printf. I still need my double quotes around the whole thing. In this case, to match my previous program, I am going to add \n to move the cursor to the next line. And now I have a crazy amount of room here. That's deliberate. Does anyone have an instinct for what I'm probably going to want to add after the quotes, but still inside of the parentheses? So answer itself. I need to somehow tell printf with a second input, otherwise known as an argument, what I want to substitute for that %s. And so I put a comma and then the name of the variable that I want printf to figure out how to plug in here. So honestly, it's a little annoying. It's kind of a dated approach, like newer, more modern languages, like we'll see later in the course, Python and JavaScript actually have much more user-friendly ways of doing it. But once you wrap your mind around the heuristics, the rules here, it's just formatting a string, like plugging in whatever you want into this format string, so to speak. And again, the comma here is important. This signifies that it takes one input at left and a second input at right. But notice this comma. There's technically two commas. But I'm not claiming that this function takes 3 inputs. Why? This comma I'm pointing out can mean the same. Exactly. This comma that I'm pointing to is part of the quotation mark, therefore part of my string of English text. So this is just English grammar. This is sort of C syntax. And again, these are sort of annoying details that we're using the same symbol for different things, but context matters. So just stare at your code, look carefully left to right, and generally the answer will pop out. No pun intended. Okay, questions now. And this is before we actually write it in one. Yeah. Why is the \n not after the answer? So the way functions work, including printf, is that you pass to them one argument inside the parentheses, and then if you have a second argument, you put it after this comma here. But the way printf works is that its first argument is always a string that you want to be formatted for you. So anything that you print on the screen has to go in those quotes. And you can perhaps extrapolate this. If I actually wanted to say multiple things in this sentence, so hello, maybe first name, last name, I could actually hello, comma, %s, space, %s. If I had two variables, one called first name, one called last name. But then I would need another comma for a third input to the function. And so it's very general purpose in that sense. Questions? Yeah. Okay, so can you abstract away the format string itself? Hello, comma, answer? Short answer is yes, but not nearly as easily in C as you can in other languages. So that's why we're keeping it simple for now. If you're going to love something like Python and JavaScript, where a lot of complexity goes away, but you'll see also in Python and JavaScript and other languages, they still are inspired by syntax like this, so just understanding it now will be useful for multiple languages down the line. All right, so let's actually do something with this code rather than just talk about what it might be doing for us. Let me go over to, for instance, VS Code again, and I'm going to go ahead now and remove this middle line of printf. I'm still in my same file called hello.c. I'm going to clear my terminal just to make extraction, and to do that I can literally type clear, but this is just for aesthetics sake, it's not functionally that useful. Or you can hit Control L to achieve the same on your keyboard. But I'm going to go back to line 5 here where I previously just said hello, comma, world. I'm going to do this instead. I'm going to give myself a variable called string. I'm going to give myself a variable called answer, the type of which is string. I'm going to set it equal to whatever the return value is of get string, asking an English question, what's your name, question mark, just a single space, move the cursor over, followed by a semicolon. Then I'm going to go ahead and say printf, quote unquote, hello, comma, placeholder, \n, close quote, comma, and I'm going to here again. This is where it's answered. And then the semicolon on the right of that. So I think now let me point out a couple of details. This got very colorful, very pretty quickly. It's not like the black and white code I got on the screen a moment ago. This is because the program that VS Code is it pre-prints, or rather syntax highlights our code for. So syntax highlighting means just add some colors to the code so that different ideas pop out. So you'll notice, for instance, that printf here, get string here, or prepper, they represent functions just like the save block. Here, what's your name, quote unquote, in VS Code is a light blue instead of white, but it's so consistent. I use strings and text elsewhere as well. So I didn't type anything special. This isn't like Microsoft Word or Google Docs or anything colors and things. This is all happening automatically, but it's just Unicode text. It's just being interpreted automatically and having these colors applied so that things pop out more easily visually. Now, I've unfortunately made a mistake, but I'm going to deliberately induce this one. YouTube will probably make this mistake. I'm going to go ahead and run make hello again to change my code, so I have to regenerate the machine code from the new source code. But unfortunately, when I hit enter now, my errors don't even fit on the screen. So let me make this bigger. I'm going to put a little caret symbol here to make my terminal bigger for just a moment. And you'll see that there's like more lines of errors than there are code that I actually wrote, often which is written pretty arcanely against programmers who've been writing code for 10, 20 years. But there are some details that pop out. So notice the problem is definitely with hello.c. So great, it is my fault. This syntax here means that line 5 is the problem, and this next 5 means character 5. So you can literally triangulate your bug, your mistake, by going line 5 and then over 5 and somewhere in that area. Specifically, the area is use a really clear identifier string. Did you mean standard in? I don't think I did, but I do want string, and there's some other complexities here. But what's important here is not the specifics of this error, but really the implication that it doesn't recognize the word string or get string. Now, why might this be? Yeah. Exactly, because we are using get string, like this specific thing that we use for unique, C does not not know about it out of the box, so to speak. I have to teach the compiler that get string exists, just like I taught the compiler that printf exists, by including it in the rate file. In this case, it's called include csv.dot. That now teaches the compiler, oh, someone else wrote this function already, get string, and we did this type of very variable string, so now if I go back to my terminal window and rerun the exact same command, and hello, crossing my fingers, now nothing in fact is wrong. Compilers are brought up to speed with all the functionality, and now we've got slash hello, enter, there it is, what's my name, notice the cursor one space over, because I thought that was prettier, you're having the cursor right next to the question mark, the ID is my input, enter, and hello, David. Questions? Any of this code thus far? Questions? Any of the code? No? Alright, so let's introduce some other functionality into the mix. It turns out that there are other types of data, other types of variables in the world, not just strings, but indeed, before we have things called integers, int for short, floating point values, float for short, a few others as well. So rather than only focus on strings, let's get a little more interested with numbers here and see what we can do with something like integers, again, int for short, by taking a look at not get string as before, but now how about get int. And for this, I'm going to give us a few other tools in our toolkit, those format codes, which I alluded earlier, like %s, fortunately are pretty straightforward. Here's a list of most of the popular format codes you might ever care about, with printf. In particular, we saw %s for string, and you can perhaps guess which one we're going to use for integers. Yeah, so %i is what we're going to use for integers. And this is the kind of thing you can consult on a menu page or a slide like this. There's only a few of them that you might frequently use. But let's go ahead and use integers in a more interesting context, not just using functions, but let's revisit this idea of conditionals. Conditionals in scratch are like those proverbial forks in the road. Like you want to do this thing, or this thing, or this other thing. It's a way of making decisions in the program, which is going to be super useful and pretty much omnipresent in any problems that we try to solve. So let me give you a few more building blocks in C by doing a side-by-side comparison again. So here in scratch is how we might say if two variables, x and y, are one is less than the other, then go ahead and say, quote, x is less than y. So kind of a stupid program, just to show you the basic syntax for scratch. This is how you ask the question. If x is less than y, then say this. So say is a function, if is a conditional, and the green thing here called what? A boolean, or a boolean expression, which is just a fancy way of saying the question's answer is true or false, yes or no, 1 or 0, however you want to think about it. In C, the code's going to look like this. So to take a little bit of some numbers developed, but you're going to say if, then in parentheses, you're going to say x less than y, assuming x and y are variables. You're then going to use these curly braces, and then if you want to say, quote, x is less than y, in C, what function should we use here? So printf. So printf, quote unquote, x is less than y. So it's a bit of a mouthful, again, notice the pattern. Name of the function is printf. In the parentheses, left and right, is the argument to printf, which is quote unquote, x is less than y. And again, just for aesthetics, move the cursor to the next line, so you don't have to worry about the scratch, because everything's in speech bubbles, we're adding \n as well. So notice that these curly braces, as they're called, much like the orange puzzle piece here, kind of like hugging the code like this. And I'll note that technically speaking in C, if you only have one line of code inside of the conditional, you can actually omit the curly braces altogether, and the code will still work. If you have one single line of code, why? Just save single piece. If you have 2 lines, 3 lines, or more in there, you need the curly braces. But I'll always draw the curly braces in class so it resembles scratch as closely as possible. As an aside, too, so you have programmed before, you might be cringing now because you really like the curly braces over here instead of here. Like that's just stylistic choice. We'll talk too about this in class. Aesthetically, stylistically, there's certain decisions we can make, but generally in a class, in a company, you as the student you employ will simply standardize on one set of rules, so to speak. So we'll use these rules for formatting our code in class consistently. Alright, any questions on this snippet of C code? Alright, a couple other things. So here in scratch, we might have a two-way fork in the road. If x is less than y, say x is less than y, else say x is not less than y. In C, it's going to look pretty much the same, but notice I'm adding else keyword here with another set of curly braces. I'm going to have a couple more printf. But in C, even though it's clearly keyboard-based, it's just text, no more puzzle pieces, it's kind of the same shape, so to speak, and it's definitely the same idea, so it's following a pattern. What about a three-way fork in the road? If x is less than y, then say x is less than y. Else if x is greater than y, say x is greater than y. Else if x equals y, then say x is equal to y. Well, you can probably see where this is going on the right-hand side. It looks almost the same. In fact, if I add in printf, it's really almost the same. At least logically, there is at least one curiosity. Seemingly a typo, it's not for this time. Yeah, the double equal signs does not match scratch, but it's not in fact a bug or a mistake in C. Any explanation of why I did use 2 equal signs instead of 1 here? Exactly, otherwise we mistake for a variable, specifically assignment of a variable. So recall that in previous code, when we used the get string function, we used an equal sign to assign from right to left the value of a variable. And that's a reasonable decision. Equal kind of means that the two should ultimately be equal, even though you think about it from going right to left. Unfortunately, the authors of C are taking themselves into a corner, and presumably decades ago, when they realized, shoot, we've already used the same equal sign. How do we represent the equality of 2 values? The answer they came up with was, alright, we'll choose 2 instead. And thus was born this decision. It's the best one who knows. Crazy enough, other languages like JavaScript have not just 1, but 2, but also 3 equal signs in a row to solve yet another problem. So reasonable people will disagree as to how good or bad these decisions are, but in C, this is what you must do. But there's a bad design decision here too. It's still correct, the code, left and right, but I do like to critique the quality of the design of both the scratch code and the C code, for reasons why. Okay, no, really good intuition. Do we have to ask this third question, else if x equals y? So short answer, no, logically, right? So based on arithmetic, if either x is less than y, or x is greater than y, or what's the only other possible answer, they must be equal logically. So technically, you're just kind of wasting the computer's time by asking this question because it already knows that that will be the answer. And you're wasting your time as a programmer bothering to type out more code or more puzzle pieces than you need because logically one stems from the other. So I can tighten this up, get rid of the else if, just use an else, and I can do the same thing over here in C, thereby avoiding the double equal sign altogether, but not because it's wrong, but because you're wasting time. Because now you're potentially asking only 2 questions, 2 Boolean expressions, instead of 50% more by asking a total of 3 questions. Other questions on this kind of code? Alright, so we have these puzzle pieces, so to speak, at our disposal. How can we go about actually using these? Well, suppose we actually want to do something with values. Let's introduce variables in C as well. We saw an example using a string a moment ago, but what about something like integers? We might not use this in scratch, but here's an orange puzzle piece in scratch by which you can create a variable called counter, count things, and you can set it equal to some value like 0. Now you can perhaps guess where we're going with this. If I in C, a variable called counter, and I want to set it equal to 0, I use a single equal sign, because logically, you read it from right to left. Effectively, it's executed from right to left. But that's not enough in C. What's missing from the screen? I need a block. So we need a data type, if it's going to be an integer, if I'm using int, and now the other mistake I can make is, so a semicolon at the end of the line. So it's a little more verbose than some languages, but if you read it left to right, this is how you tell C to give you a variable called counter of type int, and initialize it to a value of 0. That's all. Alright, how about in scratch if you want to change that variable by 1, by adding 1 to it? In scratch it's super simple. You just change it by 1 or even negative 1 if you want to go up or down respectively. In C, it turns out there are a few different ways to do this, and this looks like it's not mathematically possible, but that's not because equals is a it's not saying that counter equals counter plus 1, because that's just not possible using typical numbers, but this means take counter value, add 1 to it, and assign it back to the counter variable. So it's like increment counter in this way. Whether this is a common thing in C and programming to increase or decrease the values of variables, it's a more succinct syntax. This is identical. It might take a little practice to get used to it, but it just saves you some keystrokes. But similarly, add 1 or whatever number you use there. And this is such a common operation in C, especially that there's even a clear way of executing the same idea, and you can literally just say counter plus plus, and then semicolon in this case. All three are exactly the same, all three are perfectly correct, but you'll learn over time to type less than screens probably and save you some time. Meanwhile, if we want to do the opposite and do something like -1 in Scratch, we can similarly do minus minus in C, or we can do minus minus in C here. Alright, so just some additional building blocks translating from Scratch to C. Why don't we go ahead and try using this perhaps in the following way. Let me go ahead and yes code, and let me propose that we do something like this. Yes code, I'm going to close hello.c by clicking X. I'm going to create a new file called compare.c. My purpose is to like this program, it's going to be compare integer on screen. This time I'm not going to mess up, I'm going to preemptively include csv.h. I'm going to preemptively include standard.o.h. Here's a very common mistake in learning C. It is not studio.h. When you email us asking why studio.h is not working, that is not the word, it is standard.o.h, meaning standard input and output, stuff on the screen and the keyboard. Then I'm going to go ahead and just as before, in main void, but we'll come back to that eventually as to what it means. And now inside of main, which is just where the main part of my program goes, again, think of this being analogous to when green flag clicks, this just kicks everything off. I'm going to go ahead and do two things. I'm going to go ahead and get an integer called x, and I'm going to prompt the user for that int, and just say something like what's x question mark space. Then I'm going to do int y equals get int, quote unquote, what's y question mark space. And then let's just do something simple like if x is less than y, then go ahead and print out, quote unquote, x is less than y, backslash n close quote, semicolon. So it's not a very deep program, it's just going to do what most anything brain pretty quickly, but it's at least demonstrating how you might use now something like a conditional code. So let me go ahead and recompile this for the first time, make it compare, enter, nothing bad happens to good, dot slash compare is how I run the program, and just to see this mark, dot as we'll soon see, essentially means that the file is in your current folder. So dot means in your current folder, and we'll eventually see that dot means your parent folder, the one that contains whatever I am on my computer's hard drive. Right, so compare with x, 1. 2 for y, and hopefully it should say that x is less than y. So pretty straightforward, proof by example, we'll do this work in other cases too, but if I flip that around, and I rerun dot slash compare, and I do 2 and 1, nothing's going to happen. But you expect that because there's only one Boolean expression deciding whether or not I can actually print this out. So what's going on, well, if this helps you, you might find it useful to think about the logic of any program, be it Scratch, it's kind of a flowchart of sorts, and we'll put up a few of these over time, just in case you're a visual thinker. And this represents what it is I just did. So here in this picture is where the program starts conceptually, and anytime you see a diamond, think of that as a Boolean expression, question that's being asked. And the question being asked is x less than y. That has two possible answers, true or false, yes or no respectively. So let me propose for the arrow that if the answer is true, then print out for this rectangle x is less than y, quote unquote, and then stop. That's it for the program. But logically, if x is not less than y, then if the question answer is false, we'll just skip right to the end and stop. So this is a control flow diagram. It's just a pictorial way that we write on a piece of paper that just represents what it is the program is doing. And this gets a little more interesting if now we do something else with the code. For instance, instead of just concluding that it's less than x, less than one or the other, let's go back to the code here. Let me clear my terminal window and let me add else. So else, go ahead and print out x. I don't want to say this, greater than y. It's not quite right. What would be reasonable to say here? Yeah, settle that x is not less than y, because it could be equal, we don't know, if we're only checking two scenarios here. So if I recompile this, make compare, dot slash compare, now if I do 1, 2, I still get the same answer. If I rerun dot slash compare 2, 1, I now get
Isso aqui não funciona. Quarenta e cinco frames. 56, tá melhorando. Tá jogando bastante. Pronto. Eu botei os TVs. Então. Se fosse para os computadores. Porra. Droga. Que roda muito melhor, né? Incomparável. Ou não, né? Eu estou sendo enganado. Estou sendo enganado. Pois.
It's not as good as might be ideal, it's nice to know if it's equal to or greater than, but at least that's all the code that we have. Here. And just now make the picture, if I go back to my control flow diagram, flowchart here, this is what it looks like before logic. Now that I've added in a second branch, so to speak, now if the answer is false, I first print out x is not less than y, and then I stop the program. So same idea with the decision tree, if you will. I'm taking a 10 and getting a little bit bigger conceptually. All right, we're going to do something more than this. Let's actually have that third condition. I'm going to go back to my code here. I'm going to hide the camera mode to make room for more code, and I'm going to say else if else if x equals y, then I can go ahead and say printf x is equal to y backslash n. Alright, so now if I run it, I'm going to go back to my terminal again. Let me rerun make compare. Let me rerun dot slash compare. 1 and 2 are the same. Let me rerun it. 2 and 1 are the same. Let me rerun it a third time. 1 and 1 are now in fact equal. So this works correctly, but why did I make the point of using these else ifs? Put another way, put it on to make my life a little simpler, and just say if this, then that, if this, then that, if this, then that. Just ask all three questions. Keep the code simple. If I'm using stuff else is, would this work for me? Yeah, so it saves a little bit of time, because in this case, just like in English, this is like asking 3 separate questions, and it's not harnessing any information from previous questions in order to decide whether you should bother asking that other question. In other words, if x is less than y, you already figured that out in 1, 2, respectively, you're going to print this. Why would you waste time asking this question when it's not going to be true? Why would you waste time asking this question when it's not going to be true? And so what I wanted to make here was that if you visualize that particular design, what the flowchart looks like is actually this. And when you do it at the top, if you ask the question is x less than y, well, you're going to go ahead and say x less than y. Then if you go down to the next question, you're still going to ask is x greater than y. And then below that, you're still going to ask is x equal to y. So no matter what x and y are, you're asking 1, 2, 3 questions all the time. But if we actually go in and do what we did the first time, where if I go back to my code and I undo this heading and add back the else ifs, and now I go back to the flowchart, which I claim is bad, because it's 1, 2, 3 questions, 1 or 2 of which might not be necessary. Now if I visualize what I just did, the flowchart gets a little more complicated looking, but it's going to be better designed, more efficient. Why? Well, because if I start at the top here, I ask one question, x less than y. If the answer is true, okay, I say x less than y, and boom, I sort of cheat and go all the way to the end of the program and stop. I ask only one question. If though x is not less than y, okay, fine, I'll ask you a second question. But if the answer is true, boom, I print out x is greater than y, and then I stop. And only in a perverse case where x actually equals y, which I'm going to claim is very unlikely or infrequent, only then I'm going to ask 1, 2, 3 questions to figure out whether or not to print something at all. So this is what we mean by distinguishing between correctness of code, because it's so correct that this version is better designed, because hopefully you're going to go down this branch or this branch rather than almost one frequently. Any questions now about this code or this visualization thereof? Yeah. A perfect segue. Why did I bother even asking this question? Don't need to. When I hit the button, hopefully I got the right slide in place. This would be even better than that design. So thank you for teeing that up. This is the same picture. It turns out bigger because there's fewer nodes, fewer shapes in the picture. Notice that if x less than y, boom, we say it's less than we stop. If x is not less than y, but it's greater than y, boom, we stop. Or if it's not greater than, we immediately conclude x indeed is equal to y, and again we stop. So this picture is about as efficient and as well designed to make our logic. That's about as good as we can solve this problem. So if I go back to my code now to make my C code match that, the only thing I need to do is stop wasting the computer's time. Don't ask that third question. Just logically, mathematically conclude that of course it's going to be equal at that point in the story. All right. Any questions? Sorry, a little louder. Really good question. What if I find something that's not a number? So here too is where the CS50 library and implementation of the int will be your friend. So for instance, if I run dot slash compare and I want to compare cats and dogs, I can type in cats, enter. It's just going to prompt me again and again. It's not typing dog either. It's going to force me to give it an integer. C does not do that by default. And in fact, as we'll soon see over the course of CS50, C is actually a very dangerous language at the end of the day. Because it just trusts that the human is doing what he wants. And as such, a lot of today's software that is hacked in some ways, using C or another language called C++, are actually very vulnerable to certain types of hacking, whereas other languages can get really fast or less for reasons like this. Alright, so besides this, let's consider just one other data type now. So besides strings, besides chars, there's some others on this list here. Sorry, besides strings, besides integers, there's this other data type here in C known as a char, for a single character. So here we just tease this apart. A string is indeed a string of text. It is 0 or more characters together. A char is always precisely one character. Not all languages bother distinguishing between like a single character and a string of characters, but in C, a string is typically multiple characters. Technically 0, which ends in 1, but it's capable of being more. But a char is literally, as the word implies, a single character. Alright, given that, notice that in the CSV library, besides get string, besides get int, we also have get char. So on the other hand, we're just getting a single character from the user. Now, why would you just get a single character from the user? Well, what if you're doing something that you and I do pretty frequently when you install new software or fill out some form? You agree to some form of terms and conditions. So in fact, we go back to VS Code here, and then we propose that I create a new program called agree.c. So something akin to asking for the user's agreement. So in VS Code, I'm going to type code, agree.c, and I'm going to do some quick boilerplate. So include CS50.h, include standard IO.h, int main void, and then inside the name, like the green flag click, I'm going to do this. Go ahead and get a character from the user and ask them something simple like do you agree, expecting a yes or no response. But at the beginning of the line, I deploy the return value somewhere. So I'm going to put it in a variable called c. And in programming, you're just getting a single value. It's okay sometimes to use x and y or c. When you're using multiple larger programs, you benefit from using actual words like ant, like we did with get. But c has a specific type, so I'm going to literally say char, and then I'm going to finish my block with a semicolon. And here's now how I can check the user agrees or not. I can do something like this. If the value of c equals quote unquote lowercase y, then go ahead and print out agree backslash n. Else, if the variable c has a value equal to lowercase n, let's go ahead and print out, say, not agreed. So I'm agreeing or not some terms and conditions. But notice, these are not typos. What did I do ever so subtly different from last time I used text? Yeah. Single quotes instead of double quotes. So here's the difference when using strings, which are generally multiple characters, have to use double quotes. When using a single character, you should use single quotes around a single character. So let me go ahead now and make agree. Nothing wrong, which is good. Dot slash agree, enter, and then go ahead and type in y for yes. It seems to work. Let me run it again. Dot slash agree, n for no, and it seems to work. And just if I type in something random like question mark, I don't know, it doesn't crash. It just ignores me because I only had 2 Boolean expressions there. But notice that it's actually a little buggy arguably. Let me run it again. Dot slash agree, enter. How about capital Y? Because like my caps lock is now. Okay, it just ignores me. Let me do it again. Dot slash agree, capital N, because my caps lock is now. Okay, it just ignores me. But this should make sense because I'm literally checking for a lowercase. So how could I fix this? How could I fix this? Without just changing lowercase to uppercase, because that would then break it in the other direction. Yeah, just add another branch here, so to speak. So if variable c equals capital Y, then I can go ahead here and say printf agree, and then we close my terminal to make more room. Otherwise down here, else if c equals capital N, let's go ahead and again say printf not agree, and I claim that this would actually now work. It's way fork in the road, but I'm just checking for lowercase, uppercase, for Y and N respectively. I claim that this is correct, but this too, if you've never programmed before, should start today, to rub you the wrong way. Like, we can do better. This is the best design. Yeah. change the variable c to just be forced to uppercase or maybe forced to lowercase, no matter what we type, we just do that ourselves. So that way we can just simplify this into two possible scenarios. I love that, but we haven't seen any functions yet in C that let me change it to uppercase or lowercase. So we'll get there. But good is incorrect, other thought. So we can use or in some sense, like a logical or. Like, what I don't like about this, to be clear, is that it's repeating itself. And like, there's a principle in programming, in general, like, don't repeat yourself unnecessarily. By that I mean, I literally have the same line 10 as 14. I have the same line 18 as 22. And if anything, I literally wasted twice as much time as I needed to. Put another way, for our discussion scratch, what if I go in and just change something like, I want to be more excited, like agree? Well, I forget to change it in the other place, and let's just claim for today's purposes that that looks stupid, it's a bug, because I want it to be consistent. So don't invite situations where you might change something in one place but not another, just only write it in one place total. So I like this idea of ordering things together. So let me go ahead and delete what I just did. And just to be clear too, while this is on the screen, when you highlight code in VS Code, based on how you configured it, these dots just show you how much I've indented. Because in C, stylistically, the convention is generally to indent 4 spaces and maybe 4 more spaces, so those dots just help you count without having to manually highlight things yourself. But let me delete those lines, let me delete these lines, and this is going to look a little weird, but the way you can or two thoughts together, so to speak, or them together, is you don't say or, but you use two vertical bars, which syntactically means the English word or, and you can just ask the question, if C equals quote unquote capital R. And then down here I can say or, C equals capital N. So it adds a little more code to each of those lines, but it doesn't add redundancy, because I've not duplicated my printf. I've added more curly braces unnecessarily. Now, as an aside, there's the opposite of or. Logically is the word and. Just so you've seen it, I could do this. Ampersand, ampersand in C is how you express that the thing on the left must be true, and the thing on the right must be true. But why would this make no sense in this context of line 8? Yeah, like, at least to my knowledge, like a character can be both lowercase and uppercase. That just makes a logical sense, so indeed, or is what we want in this case. Other questions? Okay, question. By a CSP.h, is there a way to compare strings? Short answer, no, but C is going to give us that capability. Like, next week, one of the things we'll do is actually compare strings, and if you program before, you'll see in C that it actually doesn't work the way that you might expect. That's a problem too that we'll solve. But that transcends CSP. That's a question for C. Other questions on this kind of logic? Just to make this real, then, like, anytime you like click one of those URLs or like terms and conditions on a form in a piece of software, like odds are there's code as simple as this. And maybe it's graphical, maybe it's checking for clicking this button and clicking the enter key, but underneath the code is presumably some kind of conditional checking for those kinds of outputs. Alright, how about another building block from last time? You'll now translate C, namely loops, things that happen again and again. These two are everywhere in code. So in Scratch, here's how I'm out for super simple. In C, it's a little weird, but you will get used to this over time if you've never programmed before. Looks like an outfall. Okay, but let's tease it apart line by line, and you'll see that we won't have that reaction frequently. It's all going to start to look very similar to itself. But what are we doing here? In C, we don't have the luxury of these cute and fun puzzle pieces that just kind of do the work for you 2-3 times. In fact, in C, in programming in general, sometimes the work is on us to actually figure out, okay, how can I use functions, variables, conditionals, and loops, and implement some idea like repetition, like looping. And in C, here's how this might work. How can I go about doing something like printing meow 3 times? Well, I know about variables now. We're about to see loops, and I've seen how I can update variables by plusing or minusing like some value to them. Let's combine those ideas. So first, I'm doing what with this highlighted line in English. If a friend cared to ask you, like, what is this line of code doing? I'd say, what would you say? Good. It's creating a variable called counter and setting it equal to 3. I'll use slightly neutral target. I'm defining the variable would be the term arg, called counter and setting it equal to 3. So I'll use my hand to represent the counter. And that's all very good. It's like storage in some cases that I'm representing information using my hand in this case or computer's memory here. Now what happens when using a loop in C? There's different types of loops, one of which is called a for loop, one of which is called a while loop, spoiler. A while loop works like this. Inside of parentheses is a Boolean expression, just like inside of a conditional that asks a question. But this time, the question is going to determine, do you keep going through the loop again and again and again? So it's not a one-time thing, essentially getting checked again and again and again to decide when it is time to stop looping, to stop cycling. Alright, so it's asking this question first, is counter greater than 0? Okay, obviously, the answer is true, because I'm still holding up 3 fingers, so what happens? C goes inside of the curly braces, per the indentation, and executes printf of meow, which prints out a meow on the screen. The next line of code executes, which recall is the same as just subtracting 1 from counter, so I think I take down 1 finger, so I left with 2. And what happens next? Well, this you just kind of have to memorize. Once you get to the end of the inside of the loop, you go back to the beginning of the loop here and ask the same question, the same Boolean expression. So is 2 greater than 0? Okay, obviously so you go into it, you print a meow, you go into it and decrement counter further by 1, so now my hand is holding up 1. Now we wrap back around to the Boolean expression, is 1 greater than 0? Obviously, we print out a third meow, we then decrement counter again, my hand goes to 0, we go back around once more, is 0 greater than 0? No, and now the program just terminates or if there were more code here, it would just jump outside of the further braces and keep going lower on the screen. So that's all that's happening, and so this is what MIT has the luxury of doing with pictures, but at MIT someone probably essentially wrote code that looks like this to give us the illusion, the abstraction of this. So what we're learning today is sort of how they invent these puzzle pieces by just using local plumbing, if you will, like this here. Yeah? A really good question. What would happen if you created a variable inside of the curly braces? Short answer, it just wouldn't work in C, because if I were to try, with my slide here for instance, to move this line of code here, down inside of this for instance, now the very top line is trying to use counter before it even exists. So C is very literal. It reads top to bottom, left to right, and if it hasn't seemed defined to create a variable yet, you're going to get some stereo error message on the screen instead. Other questions on this here code? Alright, so if we wanted to maybe touch this up a bit, let me propose that we could do this instead. So besides this version of the code, let me just do something more canonical, more conventional. So we're totally fine with using a variable like counter, which actually by default very verbose, that's what it says. Frankly, once we come to programming, like most typical programmers, whenever they have a single integer program, you solve something like a count, they'll choose 5 for integer, like I use C for character. When you have larger programs, you don't want to start using A and B and C and D and E and F and so forth for variables, nothing's going to make any sense. But when you're doing something super simple like counting with an integer, using a short name variable totally stylistically reasonable. But I can take this up further, not just renaming counter to I, but can I do it? Okay. Yeah, sure. Okay, yeah, that's my spoiler, but while being allowed, I can take this up slightly more. Okay. Yeah, instead of I equals I minus 1, I can actually type this up this way. We didn't say the minus before, but it's the same idea, I minus equals 1, or even more specifically, I minus minus. So when you get comfortable with programming, any of these approaches are correct. This would be more conventional at this point. If you want to write code like most other people write code, adopt both of these kinds of convention. Alright, so that just does the exact same thing though, but let's now put this into practice. Let me go back to VS Code here. Let me go ahead and clear my terminal and close read.c before, and let me go ahead and create a file called meow. So code meow.c, and let me do this in sort of long. We include standard IO.h at the top, int main void, thereafter, inside there we do printf, meow, and then you know what, I can copy paste 2 more times. So I change it correct, make meow, dot slash meow, done. I've got code that prints meow complete. But this again should already run you the wrong way. Why? Because I have duplication, I literally copy and paste. And that's going to be in the future, start finding yourself copying and pasting code within the same program, you're probably doing something wrong. There's a better way to do it, even if it's correct. So this is clearly a candidate for remove. So let me go ahead and actually do that. Let me just go ahead and remove all of this duplication. Let me give myself a variable called I, set it equal to 3. Let me go ahead and give myself a while loop and check that I is greater than 0. Inside of this loop, let me print out just the meow once, but I'll reuse that code again and again, because here I'm going to do I minus 1. So that's the exact same code, the version of it that we saw a moment ago. Let me go ahead and make meow again, dot slash meow, and it still works. Why is this version better? Because if you want to catch meow 5 times, you change it in one place. If you want to make the cat dog, you change the meow in one place. Albeit changing 5 times eventually, but changing it in one place, not worrying about changing it again and again and again. But there are other ways to do this. For instance, let me propose that, and actually, let's see, let me propose that instead of just doing it this way, just to be clear, yeah, let's go ahead and propose that instead of doing this, we can actually count in different directions, right? I'm kind of forcing this idea of starting at 3, going down to 0, but with normal humans in this room, if you were to count something, you probably 1, 2, 3, and done. Like that's how we would count in the real world. Well, we can do that too here, code-wise. We could initialize I to 1. We could check that I is less than or equal to 3. And we've not seen this syntax before, but there's no easy way on a typical keyboard to type a less than or equal sign like in a math book, so we use 2 characters, a less than sign and then an equal sign, back to back, and that means less than or equal to. And this is the same idea, so long as I plus I inside of it, because that'll change, start at 1, then 2, but it won't stop then, it will go up to until I is equal to 3. Once I becomes 4, then that Boolean expression isn't going to be true, so it stops after 3 meows total. But there's another way too, and this is probably the most conventional and the way you should do it, even though it's just as correct. In CS, as you've seen already last week, we also start counting from 0. Why? Just because we're not wasting a pattern of bits. So generally, when you start writing code that counts, you should, quote unquote, almost always start at 0, count up to, but not through the total you care about, so you don't get 1 extra by accident. And so this would be the most conventional way of doing what we just described. They're all correct. You can make an argument that all of them are equally good. This is what most people, quote unquote, would do. Okay, other questions in this here? Syntax or logic? All right, how about, we've got cookies on the horizon, but before we get there, let's meow a few more times if we may. So how about doing a little bit differently versus the while loop? And I think we heard it over here. Turns out there's another type of loop altogether. So this one here, and this one, if you can believe it, is probably even more conventional than the other way. And this is going to be thematic in programming. Like there's rarely one way, one right way to do things. You're going to have bunches of different tools in your toolkit, and your code might look different from someone else's because each of you tends to reach for a different tool in that toolkit. And here's another tool, and as you proposed earlier, a for loop. A for loop is just another way of achieving the exact same idea using slightly different syntax, and it's appealing, frankly, in general, because it's a little more succinct. It just saves some keystrokes, even though you have to memorize the order in which it works. This code is identical to this code here. Functionally, but aesthetically, of course, it looks different. How does it work? In a for loop, notice that in the parentheses is not a single simple Boolean expression. There are 3 things. 1, before a semicolon, is a place to initialize a variable to do your counting, typically. Second is the Boolean expression, so it's still there, just surrounded on the left and the right by 2 other things. Lastly is the update. What do you want to do at the end of every loop through this block of code? So you can probably imagine where we're going with this. How does this work? The first thing that happens. Is that a variable called I is defined to initialize the value of 0. That happens once and only once. Then we check the condition. Is 0 less than 3? Obviously yes. So now we don't do the plus plus yet. We go into the loop. And this is where the for loop is a little confusing again. First, we print out the answer. Then what happens? There's no more lines, so we go back to the for loop and we increment I at that. So now I is 1. Then we check the condition. I is less than 3, yes, because 1 is less than 3. We go back into the loop and print the out. Now we go back to the plus plus, so I is now 2. We check the condition. 2 is less than 3, obviously, so we go back into the loop and print the out. Then we do the increment. I is now 3. Is 3 less than 3? No, so we exit the loop and we're done, or we keep going down here original code. But how many times did I say now? 1, 2, 3 total. And like, and with 0, 1, and 2. Questions on this alternative? Is actually getting YouTube, but most people will write you using for them, I would say. Yes, if you really want to be cool and say syntax, yes, it is correct and common to eliminate the curly braces if you only have 1 line of code therein. We in class will always put the curly braces there. This is the kind of thing where if you get forgetful, you go in later and add a second line, like darn it, I forgot the curly braces, things will not work as expected. So in general, use the curly braces. You do not have to. Other questions? Yes. Can you do that way? Oh, could you do it without a condition? Yes, there are very fancy things you can do. We won't focus on today, but yes, if you want to get rid of the condition, you can get rid of this here, and that would actually make the loop go forever. Which may be a good thing. It's like a clock that you want to take forever, but that's not a good thing. Alright, so beyond that, let's just go ahead and put this into context just in case you have to think about this. This is just another flowchart, if you're more of a visual thinker, that represents what it is this loop is now doing. Previously, all of our arrows went from top to bottom and stop, but now there's an arrow going back up and around because of this loop, this cycle. So when we start this program, we set I equals 0. We then check, is I less than 3? Obviously it is, so we print now, we increment I, and then we go back to that same condition. We check the condition, we print now, I plus plus, go back. Now I equals 3. 3 is not less than 3, so the answer is false, and we stop. So again, it's just another way of thinking about how the code in Scratch, how the code in C might alternatively work in each of these contexts. But there's this one other puzzle piece in Scratch we call the number key block, which is for finite numbers of repetition, but forever. And in C, there is a way to do this, but it's a little weird. is just like literally write true there. Because true is true no matter what, and it's a trick for making the loop forever go around and around, as you might if the cat live forever and meow incessantly, or if it's clock you want to take forever or the like. So here, for instance, is how we might have a cat meow endlessly using the so-called for loop instead. But recall that in Scratch we also have the ability to create some of our own puzzle pieces, and this too is something that we're going to be able to do here in C. And let me propose that we do exactly that by introducing the C analog of this. So here, for instance, is in Scratch our definition of a function called meow. For sole purpose in life, just play the sound out until it's done. This is going to look a little weird at first, but you'll notice some similarities with main. So recall the thing I typed in main, main void, that's just the when green flag click equivalent for today. But if you want to create your own puzzle piece or your own function in C, you for now literally do this. You say void, the name of the function you want to create, and then void in parentheses. And technically what this means is that this function has no return value. It doesn't handle anything back like get string or get. And the void in parentheses takes no input. It's only meow to tell how to meow, it's just only meow. So no arguments. So this literally just prints out meow. But what this does for me is it abstracts away the idea of meow. I don't need to know how to use printf, that using printf to make it have meow. I now have a function in life called meow. Because in Scratch recall I use it like this. When the green flag is clicked, I can repeat 3 times this new custom puzzle piece. But in C, I can now do this. In my main program, I can use a for loop just like we saw a moment ago, copy paste it from earlier. But now I can call my own C function called meow. And let me go ahead now and do this. If I go over to my C code here, back in VS Code, let me go ahead and delete everything inside main. Let me go ahead and do for int I equals 0, I is less than 3, I plus plus. Inside of my curly braces, let me go ahead and say meow. But I now need this meow function to exist because if I do make meow again, notice error. Implicit declaration of function meow is invalid in C99, 1999 version of C. What does that mean? Well, it doesn't know what the meow function is. And the meow function is not in csv.h, it's not in standard.h. I have to create it. So let me type out, we're going to copy paste what I had on the screen a moment ago. Void now meow, void meow void, printf, quote unquote meow, close quote, semicolon. But here too, screw this down a bit, so you can see all the code at once. Let me now do make meow. Unfortunately, I still have an error. If I scroll up, still on line 7 of meow.c, my compiler thinks that meow does not is invalid, that it does not exist. This is a common mistake, and as simple as this code might be in spirit, where did I screw up? Yeah, I need to define the function before I use it. So again, C is going to take you literally. If you try to call meow on line 7, you better not define it on line 11, you better define it higher up. So the simplest fix is going to be just to do this. Let me clear my terminal, let me highlight and just delete the meow function, and let me just paste it up here. And this will actually solve the problem. Make meow now works, and if I do /meow, that too works. But this isn't really the best solution because your solution is constantly always put it up there, put it up there, put it up there. I don't want to contrive a situation where one function needs to be above the other, but it needs to be above the other. It's just not going to work in general. And more importantly, it just pushes main lower and lower and lower in your file. The whole point of your main function is like that entry. Like that is what happens when the green flag is clicked. And so just in terms of user convention, it's just useful for main to always be at the top of the file because then you can find it. Your friends can TS can find it quickly if it's at the top. So the other solution here would be to leave meow at the bottom and leave main at the top, but this is the only time if I made a copy paste is okay. What I've highlighted here in line 11 is what's called the function's prototype. It is enough information to give you the return type, the name of the function, and the return value, and any arguments. And so if you just copy paste that one line and end it with a semicolon out there, that's enough of a hint to the compiler that okay, it doesn't exist yet, but it will, and it will look like that. That's the only time it's okay to copy paste the very first line of the function you've written to the top of the file with a semicolon so that you can make the compiler happy. So if you make meow now, still no errors, /meow, and it now works. But let me add one final feature, coming back to Scratch here, and then it's time for a snack. So here, recall, it was sort of the last fancy thing we did in Scratch where we created not only our own custom puzzle piece, but it took an input. So that we didn't need to keep using the loop ourselves, we could just let the meow function be told how many times you want the cat to meow. So in C, we don't have to make that many changes, except this. We changed the prototype to take an argument inside of parentheses, and this is the syntax for that. If you want your own function in C to take one or more arguments, you give the argument a name, n, or whatever you want to call it, but you have to tell C what the type of that input is. So it's an int n, so it knows it's a number. And then you just use n in your program. So instead of hard coding, typing manually the number 3, I'm just using n here. So this is equivalent to what I did in Scratch by just dragging and dropping n variable there. And then now we get printed that many times. If I want to then use this, notice this is the last version of the cat that we did last week. You just say meow this many times. So in C, this is where now the code gets very succinct, because all the main part of the program does is meow 3 times. So this again is an abstraction. I don't need to know, care, or remember how meow is implemented. I just need to know what its return value, its name, and the arguments. There we go. So if I make this change, I think we can get the cat to meow any number of times. Let me go back over to my C code here. Let me go back into the file and change void here to be int n, where n just means number. I could use I, but n tends to be a quantity instead of a counter. I then inside of this function am going to do a for int I gets 0, I less than n instead of 3, I plus plus, and inside of here I'll paste that meow again. I need to change my prototype to be identical, so another copy paste or just manually edit it. But now notice what's cool about main is that now I can meow maybe 3 times. Make meow, enter, /meow. Okay, or if I really want to be cool, I can change this to like 30,000 times. Go back here, make meow, increase the size of my terminal window for a dramatic pre-break first. And there are 30,000 fast cats. There are 30,000 meows. I think now let's go ahead and take a 10-minute break. We'll see you in 10. Cookies are now served outside. Alright, so we are back, and I realize this has been a lot so far, right? So there's a lot of new syntax, there's a lot of translation of Scratch over to C, but among the goals of having spent last week in Scratch and having spent problems at 0 in Scratch is that like none of today's ideas are really all that new. It's just a lot of syntax that will get more comfortable and more in your muscle memory as time passes. Up until now, though, we've focused largely on these side effects, like things happening on the screen, and that was kind of like this public hearing in the world of Scratch. But let's focus for just a bit before we then explore things we can't do very well in code, return values, instead in C. We've seen them already, like get string returns a value, get int returns a value, string and int respectively. But what if we want to make our own functions that don't just meow and visually have the side effect of meow on the screen, that actually hand us back some value? Why don't we do this in C as well? Well, let me propose that to go that route. So we go back to VS Code here. Let's take our very simple calculator that just like adds some numbers together. But the same calculator will simply get us into trouble if you understand what the computer is doing underneath the hood. Let me go ahead and run code of, say, calculator.c. And in here, let me go ahead and give myself access to the CSV library, CSV.h, the standard IO library, standard IO.h, int main void, which again we'll just take for granted today. We have to include the top end of this program, and let's just add 2 numbers together. Super simple calculator. So give me a variable called x, assign it the return value of getInt, and I'll ask the user to give us x. Give me another variable called y, assign it the return value of getInt again, but this time ask the user. For for y. And then lastly, let's just go ahead and print out the value of x plus y, but I don't think I can get away with something like this, x plus y semicolon. Because if I do this based on what we've seen before, what's actually going to get printed out? Right, literally like x plus y. So I think this is where I need the f in printf for formatting. What I think I really want to do is print out the value of the placeholder, because what do I want to substitute for %i? Maybe it's a second argument to printf intuitively? X plus y. So indeed, I can get away with this because it turns out in C, there's a bunch of arithmetic operators, all the ones that you might expect, including addition, subtraction, multiplication, division, and even this one, it's called a modulo operator, which generally gives us the ability to calculate a remainder when we divide one number by another. But I'll keep it simple with addition. And indeed, with printf, if I want to print out the value of x plus y, I can do that, but I have to tell printf what kind of value to expect, an integer, thus the %i instead of %s for string, and I think this should do the job. So let me go back to my terminal, make calculator, enter. All is also or dot slash calculator. Let's keep it simple. 1 for x, 2 for y, and indeed, I get 3 as the output. It's not very dynamic, it can't do a subtraction or multiplication or a form, but it does at least do those kinds of calculations. But let me propose now that we maybe make a reusable addition function, right? Because addition is something you're going to do a lot, and maybe it should be abstracted away with a function, just like Yam was abstracted away a moment ago. So let me go ahead and instead of doing this, let me go ahead and give myself a function called add, but instead of last time, where I had a Yam function, I'm obviously going to call this add instead. And instead of last time taking in no arguments, I think I want add to work a little differently. I don't want add necessarily to take an argument yet, but I do want add to return some type of value. Just intuitive, like what type of value should an addition function return? An integer. So again, so I'm going to change void, which means the absence of a return value, nothing's coming back, to literally int. But I'm not going to change the thing inside parentheses yet. I'm going to go ahead and copy my prototype up here, and I'm going to make this change, return x plus y, and then here, instead of printing out x plus y, let's go ahead and do this. Let me give myself a third variable for now, z equals the return value of this brand new add function that's going to add x plus y for me, and then let me print out the value of z. Instead of x plus y, I'm outsourcing now to this add function, so it will do the addition of x plus y. So similar in spirit to meowing, but the return value, like claim, we're about to create addition. So let me make calculator again, and there's definitely some errors. So here we have use of undeclared identifier x, and that's on line 17, so that's pretty far down in the file. So specifically, my compiler does not like my use of x on line 17. Wait a minute, x is clearly defined on line 8. What intuitively might explain this issue, if you've never programmed before? Yeah. Yeah, because x and y are defined in the main function, not in the add function. So the term of art here that we're about to introduce is something called scope. So scope just refers to the context in which variables exist. The context in which variables exist. So by that I mean this. On line 8 I've declared x, on line y I've declared, on line 9 I've declared y. But the catch is, and here's where the curly braces are helpful, those variables only exist in the context of the outer curly braces that are nearest to them like this. So I can use x and y on line 10, 11, 12, and even up to 13, but not thereafter. So I certainly can't use x down to line 7. But this is a problem, because an add purpose like this add x and y, but add can't access x plus y, well we have an issue with scope. Like x and y are not in scope for this add function. That's okay, because remember that every function you've seen thus far can have maybe a return value or a side effect, but it can also take 0 or 1 or 2 or more inputs, known as arguments. So what if I instead do this? Let me clear my terminal window, and then we update add to not take nothing as input, but maybe 2 integers. And I'll call them arbitrarily a and b. But I have to tell the compiler what type of arguments they are. 2 integers, one after the other. And now what I can do is this. Let me change this up here too. Int a, int b, just so that the prototype is exactly the same. And the only purpose of this prototype is just to avoid the previous error, where the compiler didn't realize add is going to exist, which came later in the file. So here on line 11 now, if I want to add two values x and y, this is now the syntax. We saw syntax in Scratch for passing in inputs to tell how many times coming out. So this is just telling add what two numbers to add together. So now I have to change this a plus b for reasons we'll soon see. Let me see if this is right. Make calculator. So far so good. Dot slash calculator. Let's do 1 and 2 for x and y respectively, and hopefully we should again see 3. Now what's going on? So here again, if I zoom in on my add function, this in here on the left, on line 15, means what about add? This means that it has a return value that it's going to hand me back metaphorically a slip of paper with an answer on it that is a type integer. It's not a word like my name, it's a number instead. These mentions of int here and here are inside parentheses, which means this function add takes 2 inputs. The first is an int, the second is an int. And just so we have something to call them, I call them a and b respectively. So what happens essentially, when I call the add function now on line 11, I'm kind of passing in x, I'm passing in y, but the add function is going to think of them as a and b respectively. It can call them anything I want. I can change this to the word first and second, and then I can literally change this to first plus second. Those are perfectly acceptable as argument or variable names, but who really cares? Like a and b with such a simple function is perfectly reasonable too. Technically, if your mind's going there, I could even call them the exact same thing, but let me propose for today, certainly don't do that, because it just confuses things. You've got x and y here, x and y here, but they're clearly different. Just don't do this. Try to come up with different variables just to keep yourself sane. But here, I have a function that takes now 2 integers, a and b respectively. It just returns the sum of them, so that I can now store the return value add in a variable called z, and then quite simply print it out. There's one other thing I can do here. Now I think about the sign. Even if you've never programmed before, do I really need the variable z? Because I'm defining it on line 11 and I'm quickly using it on line 12 and like that's it. Like sometimes you don't need variables, they might make it more readable, but just strictly speaking, and this is just kind of like substitution in math, if z is the same thing as add x comma y, well let me go ahead and just delete line 11 altogether. Let me get rid of mention of z. You can actually get away with doing this. And much like the join block in Scratch, where I kind of overlaid it on the say block, like kind of stacking them, you can stack functions in C or nest them really mathematically. Honestly, it makes it a little harder to read because your mind can kind of dive into deeper and deeper into this second argument, but it's perfectly acceptable too. And just to connect the dots and maybe something from high school, this is kind of analogous to a function in math class being like f of x, where f is some function name, x is some arbitrary input to that function, and when you start to put functions inside of functions, so that the output of one becomes input to the next, it's like using this syntax, f of g of x and so forth. If you've never seen that before, don't worry, but if you have, it's a way to connect some of these dots. Any questions though on just this idea of now having a function that doesn't just have a side effect, but instead has a return value? Yeah, I'm back. In our definition of main, what did I do? Oh, a really good question that I'm trying to sweep under the rug for today, but in every one of our programs thus far, I have indeed said int main void. Technically speaking, whenever you write a program and it finishes running, it actually returns a value somewhat secretly. It returns the number 0 by convention, which means all is well, and it can return any other integer if something goes wrong. In fact, on your Mac, PC, or even phone, if you've ever gotten like a weird message on the screen, like something went wrong, and it's like a weird numeric code, like error negative 129, something arbitrary like that, that tends to mean that some program running on your Mac, PC, or phone had something go wrong with the main function, and that is the number that is returned, but that's more than we want to talk about today, but we'll come back to this. But main always returns a number, by default, it is 0. All right, so with that said, let's actually tease apart what it is we've been using underneath the hood here a little bit by returning to VS Code's interface itself. It turns out that all this time, even though I keep alluding to Mac OS and Windows, which like 99% of us are probably running on our laptops or desktop, there's actually other very popular operating systems in the world, among which is Linux. So Linux is a very popular operating system, the thing that turns on, the thing that boots up when you first turn on a computer, and it's very commonly used for servers. Nowadays, all the CSF's own servers run some version of Linux. Those students more comfortable sometimes run Linux on their own Macs or PCs even. So Linux is a very popular operating system, and it's particularly characterized by its textual interface. It's command line interface, even though it also comes with graphical ones as well. So again, this term we started today with a graphical user interface is something with menus and buttons. It's literally what you and I use every day on our devices, otherwise known as a GUI. But today on, we're going to get more comfortable with and more practice with this terminal window down here, which represents a command line interface or CLI. And just so you have a mental model of what's going on in the cloud here, when you access cs50.dev, you are accessing this version of VS Code in the cloud, a piece of software just running in a browser. But that piece of software is automatically connected to your very own personal server in the cloud, so to speak. Technically speaking, it's a Docker container, but it means that you're essentially your own mini server in the cloud that only you have access to. And that server or container is running an operating system called Linux. And in fact, every time I've been running a command down here, whether it's code or make or /hello or anything else, I've been running commands from here in Sanders Theater on a server somewhere in the cloud, my own Linux container or server, and you'll have the same yourself. This is the thing that we have pre-configured for you by installing the compiler and so many other pieces of software you'll soon see in the class. But underneath the hood then of Linux is a, I assume, familiar environment that allows you to run different types of commands. And those commands include things like this. And this is something you'll develop muscle memory for over time. I'd like to give you a sense of some of the most popular textual commands, because we're essentially about to take away some of you have from a GUI world and have you type out words that represent double-clicking on things, dragging on other things, and other such commands that you might take for granted. It'll be a little painful at first, the first days or weeks, but it will make you far more productive long-term. So that even after CS50, if you start using your programming skills in some other domain, class, or real-world job, you'll just be a lot faster at the keyboard and able to do more work more quickly. So with that said, let's go back to VS Code over here. I'm going to open up my file explorer over here. You're going to see I have all of the files that I've created thus far in class and all of the programs that I've compiled thus far in class. I also have the source one directory, which you can download from the course's website, which has all of today's code pre-written in advance. You can type everything that I really type, but all of these files are things that I created. You'll see that in white are the C files, and grayed out are actually the binary files, the machine code that I created that I was running. So you can click on any of these files in VS Code to open them. For instance, here is hello.c, and voila, it opens in the text editor. But if I try to open hello, that's not going to work, because that's zeros and ones. And frankly, the computer could show you all those zeros and ones, but it's just not going to be useful. And honestly, it's too easy to make one mistake and break the whole thing. So instead, VS Code says that you can't display the text because it's binary, or maybe even supported more generally. So know that you want to only click on the .c file for writing C code. But let me go ahead and do something else. Suppose that I decide that, wait a minute, we're near the end of class, we're not done yet, but what if I want to change hello.c to goodbye.c, or if I want to change now.c to whoop.c, turn it into a doll. Well, let's actually do that. I could go over here and right-click or control-click on the file, just like on a Mac or PC. I can find the rename option and I can do it all via GUI. But you should get more comfortable using commands like these here. And among the commands on this list are mv for move, aka rename. So for instance, if I want to change meow.c to be woof.c instead, I literally type mv space, the original file name, space, and the new file. So this is very similar to what I've already been doing with the code program or the make program. Not only type the name of the command, but also the thing that I want to code, the thing that I want to make. In this case, I type the thing that I want to move from old to new. Now, if I can enter and watch on the left-hand side, meow.c in the GUI should automatically change, even though I'm doing this all via the command line keyboard interface. Alright, it's not all that exciting. This is just to say that they are one and the same. One is a GUI, one is a CLI, but it's the same exact thing. Moreover, we're going to close now the GUI and the so-called Explorer. And in my terminal window alone, now I'm kind of at the file. This file I created earlier. Well, there's other commands as well. On this list is essentially ls, which lists the command, lists the file in your current folder. And as you might have named mv remove ls for this, like CS people like to be succinct, terse, and type the minimal number of keystrokes. That's why these are all abbreviated commands instead of full words. But if I go back to my terminal window, I type ls, voila, there is exactly the same contents of my server, but displayed textually. And there's some heuristics here. In green, with an asterisk, is all of the programs that I made with make. They're executable. So the asterisk just means it's executable, / Meanwhile, the source one directory, which only I have, because I downloaded it in advance, as a slash to indicate that it's a folder instead of a file. All of these white files ending in .c we created together here today. Now, what if I really am embarrassed by my very first program, hello.c? Well, I can very destructively go and use the rm command for remove. And rm, hello.c, is going to prompt me, a little cryptically, remove regular file, hello.c. And amazingly, this rm program has code just like we wrote earlier for agree.c, where I can type y to delete it, I can type n not to delete it, but let's delete it. Let's go ahead and hit y, enter. Nothing seems to happen, but in general, that's a good thing. But if I type ls again, notice what is now missing. And in fact, the list is a little shorter, so it's 1 line instead of 2. Hello.c is now gone. Now, if you do that, there are not easy ways to get the file back, so don't do that unless you really want to. But there are backups maintained in these files as well. Well, what else is there too? Well, there's all of these other commands you'll experience over time, like cp is copy, mkdir is make directory, or mdir is remove directory. And for instance, let me show you one more folder. If I type ls, there's that source one folder that I claimed I downloaded in advance. If you want to see what's there, you can type cd for change directory, source one, enter, and voila, notice that your prompt has now changed. And let me clear the screen, just as a visual reminder of where you are. You can see before the $sign down in the folder that you're inside. So in Mac or Windows, you see obviously the folder. Here you just see a little textual reminder of where you now are. And if I type ls, you'll see that I wrote a crazy number of files before class, and each of these represents different versions of the files. I'm coding in real time that I usually have printouts of, so go through things in series, so you have copies online as well. So in short, all of these commands, if you haven't used them before, they will soon become like muscle memory, and they do the most basic of operations, but there will be other commands that you see over time that do even much more than that. So let's go ahead now and solve some actual problems. And it's no coincidence that it keeps showing for Luther Super Mario Brothers as a form of older game Nintendo Entertainment System that allows you to ultimately have this two-dimensional world where Mario moves up and down and side scrolls from left to right, but you'll see we can distill even some aspects of Mario into some fairly representative programming problems. And in fact, let me propose to consider this screen, the original Super Mario Brothers. So there's these four bricks of rocks on the sky, you see the question mark, and if you click on one of these, if you jump to Mario, you jump underneath each of these question marks, you get like a point or something else that pops out. Let's distill this so we test that and consider and see how can we make not a blue sky yet, not a green grassy hill and so forth, how can we just make 4 question marks in a row? Because I dare say that we do have these building blocks by way to do this. Well, the simplest way might be to go over here and run code of Mario.c, and then in Mario.c, let's include standard IO.h, have printf, let's do int and void, as we keep doing inside of main. Let's keep it super simple. 1, 2, 3, 4, /. Doesn't get much simpler than that. It's not going to be the prettiest of names, but if I make Mario now, /Mario, I get my 4 question marks in the sky. All right, so it's not all that interesting, but this is clearly a candidate type of programming feature. not to scratch, to make it more interesting, yeah. So some kind of loop, right? So print the thing out iteratively instead. So let me do that. Instead of just printing this out all at once, let me go ahead and remove this. And for int I gets 0, I less than 4, I plus plus, and then in here, let me go ahead and print out just one question mark instead. And now let's run this. So make Mario to recompile it. Dot slash Mario. Does anyone not want me to hit enter yet? Why? Yeah, it's going to print out a new line every time. So notice, it's 4 question marks, but they're on each on its own line. All right, let me fix this. It's obviously because of backslash n. So let me remove that. Let me rerun make Mario. Dot slash Mario. It's better in one way, but worse in another. So wait, but now the dollar sign is doing that thing where it's on the same line. It's so stupid. Everything else. So how can I fix that? Yeah, so logically, we don't have that many building blocks today. So a lot of syntax, not that many new ideas. Let's just use printf to print out literally one and only one of these backslash n's outside of the loop, so it happens after all 4 of those have been printed. All right, you can make Mario again, dot slash Mario. Now we're back to business. So sort of silly syntactical details, if you reduce the problem to its essence, it should hopefully logically become clear over time. All right, well, how about something that way vertical? We've done something vertical already, so I can actually change the program and print out 3 bricks instead of 4 question marks. But what if we consider a 2-dimensional world? Later on in the game, underground, everything will take lots of bricks. So let me propose for the sake of discussion that this big wall here is like a 3x3 grid of bricks. So it's not a single brick, it's like 3 by 3 or 9 total. Now we're getting interesting. And let me go back to Mario. I could kind of take the easy road out and say, all right, well, let's print out about 1, 2, 3, backslash n, close quote, and then, okay, we have to compute case, and I'm using hashes instead of the actual bricks, but that's pretty close. Let me now go ahead and make Mario again, dot slash Mario. It doesn't quite look like a square, because it has a little color on the RY, which is correct, but not well designed. So here too, what would be better designed than just hard code, typing literally all of these hashes. Yeah. Interesting. 2 loops, why 2 loops instead of 1? Okay, so so one vertical, one horizontal, even though these are like multiple typewriters, you might know what we're called, if you get a piece of paper into it, you can sort of print like line, then it scrolls, line, then it scrolls, line, then it scrolls. This is kind of how the terminal window works too. You print rows and columns, but you have to print one row at a time, one row at a time, one row at a time. It's not easy, but it is possible to like go backwards and sort of go up and down, just going one row by row by row, it's typical. So how can I do this? Well, I can use at least one and maybe even indeed 2 loops. And this is where we're just now composing different ideas for today and even last week. So let me go ahead and say for int I gets 0, I less than 3, 3 by 3 grid, I plus plus. And now let me cheat slightly. Let me print out just 3 of these here. And that's it. So I'm kind of cheating. I'm printing out rows dynamically, but I'm still printing 3 columns all in one rep. But let's see what happens. Make Mario, dot slash Mario, and it does work. But what if you said I want 4 by 4, or 5 by 5, or 6 by 6? Now I have to change like 3 to a 6, and I have to add another 3 hashes here. Like things get messy if you don't do this mathematically. So let me now do this instead. Why don't I go ahead and print out every row at a time? But for each row, let me use another loop to decide left to right how many do I want to print. So to do this, I can do another for loop. I can call this variable something different. J is pretty common. You start at I, you go to J. If you go past K, maybe L, you're probably doing something wrong. You don't want nested loop, but 2 is okay. J equals 0, J is less than 3, J plus plus, and then here I can print out a single one of these. And no new one. I don't want to screw up like I did before, so I'll just do one. Let me go ahead and do make Mario now. Dot slash Mario. Can I hit enter? This is not correct yet. It's going to look like a single line of 9 hashes, I think, because I never used a single backslash n, so that looks wrong. So on between what line number should I insert a printf of backslash n? Let me look a little farther back if I can. How about here? Between 10 and 11. So I'm going to go over here. I'm going to add printf quote backslash n semicolon. Let me go back and recompile Mario. Dot slash Mario. And cross my fingers. Voila. Perfect. I printed out now 3 by 3. Now it's correct. It's not. If we want to be really nitty, maybe still not the best design. Where am I perhaps repeating myself? But yeah. Yeah, it's Machinist wheel, but now I have 2 people call these magic numbers. Magic in the sense that where did that come from? Just randomly put it in the middle of your code, and also put the same thing here. Now I have to make sure I don't screw up and make one change and not the other. So it turns out that we factor these out. I can actually do something like this, int n equals 3, and then I can change this to n and this to n, which is marginally better because now I only have to change n in one place if I want to make something bigger or smaller. It's still going to work the same. So make Mario, dot slash Mario, there's our 3 by 3, but I want to 5 by 5. Let me change the n to 5, rerun make Mario, dot slash Mario, and now it's a bigger grid, 5 by 5. But this is a little fragile. It turns out there's another trick we should introduce. It turns out that C supports what are called constants, whereby you have a variable that you want to exist, is useful, but you don't want to accidentally change it. Or if you're working with a partner in class or a colleague at work, you don't want your partner or colleague to accidentally change that value with their own code. You can go into your code and tell C, this is actually a constant integer, a constant, so to speak. And this is just to prevent you or someone else from doing something stupid by accidentally changing it elsewhere. The code is still going to work the same, dot slash Mario, but you won't be accidentally able to change it very easily to something else. And honestly, what we've now done too is set ourselves up to make this more dynamic. Let me go up here, let me add a CSV library so that we have access to get in, because now we can do something fancy like ask the get in function for the size of this brick wall. And then we can use n dynamically. So for instance, let me increase the size of my terminal, make Mario, dot slash Mario, size 3, gives me a 3 by 3. Dot slash Mario, size 5, gives me a 5 by 5. Dot slash Mario, about 50, gives me a crazy big one, but it's all dynamic. Now I don't have to change the code, it just now works. As an aside, if you wonder how I start back, science is something up arrow. It turns out that Linux will remember if you configure all of your previous commands. So if you hit up, I can go through the past, a couple hours of commands that I type, which is useful sometimes, a couple hours of commands in the past view, just to save yourself some keystrokes. And another trick in the terminal window is to do this. If I do dot slash MA and I get bored and I want to type out bar IO, I can also just hit tab and it will autocomplete based on the characters I do. So those kinds of tricks too will save you time over time. But let's do this. It's kind of broken, arguably, if I do this. How about cat? All right, well, that works. That prevents you from doing something stupid, because get in only accepts integers, but it will accept 0, which does nothing. It will accept -1, which does nothing. And that's not bad. It's not doing something weird, but it would be nice to catch that and force the user to give us a positive integer instead, so we can see something on the screen. So let me go back to my code and propose that now that we have the CSV library, why don't we do something like this? I'm going to change this and get rid of the constant, just in case the user needs to type it again. And what if I do this? While n is less than 1, so if it's 0, -1, -2, or whatever, let's go ahead and again ask the user for an int and ask them for the size again. And therefore, only once n is not less than 1 will this loop break out and we'll proceed with the rest of the code. So now let's try this. Make Mario, dot slash Mario, 0, didn't like that, -1, didn't like that, -2, didn't like that, 3, it did like that. So using a loop now, I can sort of ensure that the human is providing me the input that I actually want. So this is correct, but I dare say 6 through 10 could be done better. Why is it poorly designed, instinctively? Yeah. what repetition do you play? What lines? 6 and 9. Like, okay, so they're literally the same. That's generally not a good thing. And maybe I can change this one to remind the user, like, hey, that's not a positive number. So you might want to customize the message, but just having copy and paste here for the most part is not a good thing. So it turns out there's one feature of C we want to introduce today. It turns out there's one other way that will actually help us eliminate this redundancy of using get twice, and particularly asking literally the same question, size, twice, and duplicate. So I'm actually going to go into my code here, and I'm going to delete the loop as we've written it thus far. And instead of using a while loop, I'm going to introduce instead something that we typically call a do while loop, which is a little bit different. Indeed, we begin with the keyword do, and then inside of the curly braces, what I'm going to do here is that thing I might want to do once and more times thereafter. So for instance, I'm going to say n equals get underscore int, quote unquote size, and then at the bottom of this block of code, then I'm going to use the keyword while, as well as parentheses as always for a Boolean expression. And here I'm going to ask the question, do this while n is less than 1. But there's one fix I still need to do here, because notice on the current line 8, I actually haven't given n a type. I haven't declared n yet. But it would not be correct to declare n here, inside of that do block. But why might that be? Why would it not be a good thing to declare n inside of these curly braces? Yeah, so we call that definition of scope. We call that the scope of a variable is generally confined to the most recently open curly braces in which that variable is declared. And so if I declare this variable on line 8, I'm not going to be able to use it on line 10. But there is a fix, even though it might look a little strange. I'm going to go above my do block here, and before I go into this loop, I'm actually going to declare n to be an integer, but semicolon, end of block. I'm not going to bother giving it a value because I know logically I'm going to end up giving it a value anyway, now on line 9. And so what's different about this version of the code is that the do while loop ensures that we prompt the user for input at least once, and then while that input is not what we expect, for instance, less than 1, then it's going to execute again, and this message does that, do the following while this Boolean expression is true. So if I go ahead now and rerun, make Mario, compiles okay, /Mario, and now I'll go ahead and input something that's not correct, like 0, but I'm prompted again. I'll input something like -1, and I'm prompted again. But if I go ahead and input, for instance, 10, now, because that's a positive integer, I indeed get a 10 by 10 grid of those. And there's one other thing we should introduce here to C2. C supports comes. A couple of you asked about this and come from other programming languages. Suppose I want to remember what it is I just did with this program. Let me go into line 5 and 6 here and do / prompt user for positive integer. This is what's known as a comma. It's grayed out only in the sense that the compiler is not going to care about it. The computer is not going to care about it. This is a note to self, like a sticky note in the context of Scratch. And it starts with // which essentially tells the compiler, ignore this is for the human, not for the computer. But this comment, so to speak, is a way of reminding yourself, reminding your colleague, reminding your TF what it is a few lines of code are meant to do. And now this comment might be print, and how about n by n rid of bricks. And what's nice about comments is that theoretically, you can get away with it. Someone else can get away with just reading this comment and then like not even look at the rest of the code. They can look at this comment and not look at the rest of the code because you describe for them what it's meant to do. Yeah. Correct. The hash line in Python as a comment is not the same thing in C. In C, hash include needs to include the library's header files in that way. Other questions? All right, so as promised, what is maybe C not actually good at? Well, let me propose that we consider what's actually inside. Computer. At the end of the day, whether it's a Mac, PC, iPhone, Android phone, or some other computer device, there's something that looks like this. This is memory, otherwise known as RAM, or random access memory, for reasons we'll get to in a few weeks. But this is where data is stored. This is where hello world is stored. This is where 1 and 2 and all of those numbers are stored. Any data in your program is stored ultimately in the computer's memory. And the most important takeaway for today is that all of us only have a finite amount of memory in our devices. You might have a high-end device which has a lot of memory, but it's still finite, which means you can only count so high with that device. You can only store so many files with that device. There are fundamental physical limitations, even though mathematically, theoretically, you should be able to count toward infinity. So what are the implications for this? Well, consider this. In the world of numbers, as per week 0, if you're only using 3 digits, and I've grayed out the fourth one just to make a point, if you're only using 3 digits, we can count from 0 to 1 in decimal, to 2, to 3, to 4, to 5, to 6, to 7, and as soon as you count to 8, you technically per last week need a 4th bit, but if you don't have it, the number 7 might seem to be followed by what number instead? 0. The sort of number overflows, so to speak, right? You carry the 1, but if there's no place to put the 1, because there's no 4th light bulb, if there's no 4th transistor, if there's no 4th bit, the lower bits, the zeros, are going to be mistaken for the number you and I know is 0. So integer overflow is a thing in computers, whereby if you don't have enough memory, if you count high enough, the number will wrap around back to 0, or sometimes it will wrap around to a negative number, depending on whether the code supports negative and positive numbers and 0 alike. So that has some very real-world implications, integer overflow. That's sort of a fundamental limitation of how numbers are typically stored. Now, thankfully, we typically don't store things based on number of digits, but number of bits. And a bit is just a 0 or 1, and recall from last week that a common unit of measure is minimally 8 bits, or a byte, but even more commonly is 32. So for instance, here are 32 bits, all zeros, and if you do out the math, this is the number you and I know in decimal, is of course 0. But if I change all 32 zeros to 1s, this is a really big number now. If we're only using positive numbers, not negatives. What number roughly is this? 32 ones. Roughly 4 billion in total. Roughly 4 billion in total. Why? Well, if you've got 32 bits, each can be 2 possible values, 0 or 1. That's 2 to the 32nd power, which is roughly, I'll stipulate, roughly 4 billion total. The problem is, what if you want to count to 4 billion and 1? It's a bit of a white lie, not quite precisely that, but what if you want to count just higher than that? You need a 33rd bit, because all of the others are going to go to 0 at that point, and you might count from 1 to 2 to 3 to 4 billion back to 0. Or worse, if you're dealing with negative numbers too. So the fact that there are finitely many bits used in computers is a problem, and negative numbers do add complexity because this is specifically the 4 billion in question. 4,294,968,290. That is as high as you can count, 32 bits, if you don't bother with negatives. But if you want negative numbers, you got to have that, because you got to save half of them for negative, half of them for positive, give or take. And so if you're supporting negative numbers, as you probably should for a calculator, Microsoft Excel, spreadsheets, you can only count as high up as 2 billion, roughly, or negative 2 billion, roughly, instead. So it turns out that when you are using data types in C, you have some control over how many bits you actually use. And this list is longer than we covered today, but we did talk about integers for a while. Those are by convention nowadays 32 bits. If that's not enough, you can upgrade your variables to longs, which tend to be 64 bits instead, which isn't just twice as big as an integer, it's actually 64 bits, which is exponentially more. It's an unpronounceable number, at least for me. That's a crazy big number when it's available to you. Moreover, you can see this if we actually are a little reckless with how we're using code. And just so you know too, though, there are functions even in C++ library that let you use these larger values. You get long, of course, we'll get you a long, and this one's a little non-obvious, but %li is the format code for printf, just so you know, we're printing a long integer and not just an integer. So it's 2 characters instead of 1. Suppose, though, we actually want to use code involving some large numbers, it turns out that certain bad things can happen. So let me go ahead and do this. I'm going to go back over to VS Code here. I'm going to modify my calculator to do something that at glance should be perfectly reasonable. Let me go ahead and open up calculator.c as before, and where we left off we had this add function. You know what, I'm going to simplify it back to its very original version. I'm going to go ahead and get rid of the add function and just distill it to its essence, which is not to add anymore, but let's just do division. I want to print out this time maybe x divided by y. So here we go, x divided by y is a nice simple program in my calculator. Let me do make calculator again, /calculator, and let's divide something like 1 divided by 3, which should, okay, weird. Give me 0 instead of probably 0.33333, as you might have expected for 1/3. So what might the takeaway there be? Why am I saying 0? Perhaps, yeah. Yeah, so 0 is an integer, and indeed that's what I'm telling the thing to print. And in fact, if we go over to my little cheat sheet here of format code, I'm currently using %i. I should actually, when I do division of numbers that might have floating point values, decimal point that float left to right, otherwise known as a real number, I want to use %f for float instead. So I'm actually going to go back to my code here. Let's try this. %f instead of %i, and let me go ahead and make calculator. All right, well this didn't work then. Format specifies type double, but the argument has type int. All right, so that too is not quite working. So I think I actually need to make a change here further. Let me actually go ahead and do this. It turns out that besides integers, there are these things called floats, and also double. Float uses 32 bits, and a double uses 64 bits. And that doesn't necessarily mean you can count higher, as much as it means you can have more numbers after the decimal point. So if you want a more precise value, you throw memory at it by using a double and 64 bits instead of a float. But we'll keep it simple. Let me go ahead and do this. Let me just do the math using the type of variable that I should be here. Let me do not int, but float z equals x divided by y. And now let me go ahead and print out the value of z. Strictly speaking, I don't do the variable, but I'm trying to be pedantic and actually use a float explicitly this time, so we see a real number. All right, let me go ahead and do make calculator. /calculator 1 divided by 3 equals, damn, now it's just showing me more zeros, which clearly isn't the case. Well, this is because of an issue that we'll generally call truncation. So truncation is just a term of art. That means if you take an integer and you divide it by an integer, even if you get a fractional value, the fraction just gets thrown away because you're only doing integer-based math. So if there's anything after the decimal point, it just gets truncated, literally discarded. So what should 1 divided by 3 be? Obviously 0.33333 ad nauseum. Unfortunately, you throw away everything after the decimal point, which leaves you still with just 0. And even though I'm seeing more zeros, that's because we threw away all of the 3s. That is just what happens when you use integers and do any kind of division like that. But there is a solution. We can actually convert or cast integers to floating point values. We can tell C, I know this is an integer now, but go ahead and treat it as though it has a decimal point, even if it's 0.0 at the end of the number. So I can go into this, and I can use parentheses, and literally write float in parentheses, and over here for y, I can literally use parentheses and convert y to a float. The term of art here is type casting. You're converting one type to another effectively, or technically treating one type as though it's another, even if it doesn't necessarily have a mathematical impact. But what it means now is that z will be defined by dividing one float by another, so truncation will not now happen. So let me do make calculator, /calculator, and now 1 divided by 3, there it is. Now the math is actually correct. But my god, we had to sort of jump through hoops just to get this to work. So to be clear, the two issues, the issue we encountered was truncation. If you divide an inch by an inch, you will get an inch, no matter what it should be mathematically. But if you instead typecast the values, the variables, to a floating point value, or double for that matter, then a float divided by a float will give you a float and preserve all of those 3s. But here's another catch, or at least a limitation potentially with computers. What if I go ahead here and let me do this. Let me show you one trick here. The syntax is a bit weird. Instead of printing out %f alone, let me print out maybe 5f. So this is weird syntax, and it's only specific to printf. %.5f means show me 5 decimal places specifically. So if I do make calculator, /calculator 1 3, voila, I get 5 decimal places. If I want 6, let's do this. I'll change the code to 6. Make calculator, /calculator 1 3, and now I get 6 3s instead. All right, well, wouldn't it be nice to be even more precise? Let's give me 20 significant digits after the decimal point. So make calculator, /calculator 1 divided by 3, and so the middle school teacher seems to have lied to you at this point. 1 divided by 3 is apparently not 0.33333 with a line over it, or just infinite number of 3s. Okay, that's not quite the right conclusion though. Whoops. Why might I be seeing these weird numbers instead of just lots of 3s? Intuitively. Why this rounding error? Yeah. Exactly. The computer only has limited memory, finite memory, so it just can't represent every possible number in the universe, because we know from grade school there are infinitely many of those numbers. So what you're essentially seeing is the closest it can actually get. It's rounding to the nearest floating point value, if you will. And it also relates to how numbers themselves are represented in memory underneath the hood. I can do a little better though. Let me zoom out and let me upgrade, so to speak, from 32 bits to 64 bits and use doubles instead. I can still use %f. There's not a percent. You don't use %d for double. Let me do make calculator again. /calculator 1 3. I get more 3s, but still some rounding. It's more precise, but it's not 100% accurate, because that's just not going to be possible in terms of the computer's memory. So this is a whole other issue known as floating point imprecision, which is another type of limitation. We saw integer overflow. If integers can only count so high before you sort of run out of bits and things wrap around, floating point imprecision means that you can't possibly represent the infinite number of real numbers that exist in the universe if you only have a finite amount of memory. You would need an infinite number of bits, it would seem. So these are two issues that actually fundamentally can influence the correctness not only of your code, but code in the real world. And case in point, back in my day, I graduated in 1999. A lot of the world thought the world was going to end around then, because around the time the years rolled over from 1999 to 2000, there was a lot of old software still running in the world. And in fact, that old software, reasonably so, only used 2 digits to represent years. Why? Memory was very expensive early on, and if you could use half as much memory to store a year, that was a win. That saved you money, that saved you memory. The problem, though, of course, is that a lot of old software from the 70s and prior was still running in 1999, and unless companies or individuals updated that software, 1999 might be mistaken for the year 1900 instead of 2000, because all the code just assumed that, of course, we're talking about the 1900s. The code's not going to be running 50 years later, but it was still inaccurate. So people had to scramble, and they essentially had to solve this by using more digits, so upgrading from 2 to 4. Nowadays, and really since the 70s too, we use 32-bit integers to keep track of time, specifically keeping track of the number of seconds using an integer from January 1st, 1970, the so-called epoch, whereby that's just an arbitrary date early on, where we just started counting time. So all of the clocks in your Mac PCs and phones pretty much just have a single integer that gets updated every second, but it's just keeping track of absolute time per se, how many seconds have passed since January 1st, 1970, just because that's the date humans chose. The problem is you can only count as high as 4 billion, give or take, with 32 bits, and actually 2 billion, give or take, if you support negative numbers as well. And the problem with that is that we're about to trip over the same issue again, and not too long from now. This is the 2038 problem, because in the year 2038, on that date, mark my words, words, things could break again. Why? Because that 32-bit value is going to accidentally wrap around back to a 0 or a negative value, so we go through the whole darn process again. Now, thankfully, the solution, as you might expect, is kind of just to kick the can even further down the road and use 64 bits, which I think will get us another 290 million years of runway. It's more than twice, so it's not our problem anymore at that point, but that's fundamentally going to be the solution, but it will still be finite. So we're just deferring to our descendants to actually deal with the issue some millions of years from now. These things are still running. So if that does happen, here's the specific date that in 2038, all of a sudden our clocks will still think this negative number will get subtracted to the current epoch time, so we'll think we're back in 1901. So this has had some fun and very real-world implications. So for instance, this is the game Pac-Man, which you might have played, kind of came out around my day back in time, and if you get to the 256th level, this unfortunately is what happens, because they didn't really expect the players to spend all this much time playing Pac-Man apparently, and they didn't really have a condition saying you win if you get to the 255th or 266th level, and so what happens here essentially is that the whole screen gets very garbled, because there's an integer in the original Pac-Man that counts to 256, but that's too big, so it wraps back around to 0, and it doesn't sort of know when to stop printing fruits on the screen, as in this case to collect. Another example of this is actually from the original Donkey Kong game, which looks something like this in my day too, whereby in Donkey Kong, there was this mathematical formula, whereby the number of seconds you have to solve the game was a function of 10 times your current level number plus the number 4. That dictated how many seconds you get, so of course, the higher the level, you get more and more time as the level climbs. Unfortunately, once you hit level 22, the math ends up being 10 times 22 plus 4, which gives you the number 260. And they too were using 8-bit values, a single byte to represent numbers, which means 260 is bigger than 256. And the way that math worked out was 260 minus 256, it wrapped back around, gave people 4 seconds to solve level 22, which is just impossible. Like Mario can't even get up a couple of levels or so from where he actually was. So that too was sort of a well-known bug as well, since that works out from there. Lastly, and this one is all the more real, in 2015, Boeing 787 is documented as having not a hardware bug, but a software bug in the following sense. A Model 787 airplane that has been powered continuously for 248 days can lose all of its power due to the control unit simultaneously going into fail-safe mode. This condition was caused by a software counter that will overflow after 248 days of continuous power. Boeing at the time was in the process of developing a CPU software upgrade that will remedy the unsafe condition. People did the math. It turns out that Boeing was probably using an integer that was 32 bits, and they were keeping track of time, not in seconds, but hundredths of seconds. Because if you do out the math, after a 32-bit value has reached 4 billion, or 2 billion, 100ths of a second, the number wraps around back to 0, or negative 2 billion. And the implications was literally the plane's power would stop. And if you can believe it, if you grew up with Windows, Mac OS, or whatnot, anyone want to conjecture what the solution was until Boeing updated their software? Turn the plane off and turn it back on, because that has the effect of resetting its memory and therefore all of its variables back to 0. So this is ultimately to say, as you dive into problem set 1, you're first in C, you too will make quite a few mistakes when it comes to correctness. You too will encounter opportunities for better design and better style. In the real world, there are very much these issues, so even if you struggle, know that for better or for worse, you're in very good company, but some 3 months from now, you will be in much better shape, because this was week 1, and this is CS50.
Plötzlich